welcome our two distinguished speakers, Mr. Suresh Mikili sir and Mr. Rohit Kadam sir. We are grateful for your virtual presence. Without further delay, it's my pleasure to introduce our esteemed speaker for this session, Dr. Suresh Mikili sir, for the session number 9 about the role of IoT industrial automation with case studies. Dr. Suresh Mikili sir is an associate professor in Department of Electrical and Electronics Engineering at National Institute of Technology, Goa, where he has been serving since 2013. He received his MTech and PhD degree in electrical engineering from NIT Rockville in 2008 and 2013 respectively. His research expertise spans smart electric grid, electric vehicles, photovoltaic systems, power quality, wireless power transfers, and soft computing applications. He has authored two books with CRC Press and was recently selected by AICTE to write a technical book on a power system one. With more than 135 publications in reputed SCI journals and conferences, his work has been widely recognized with over 2,900 citations, an H index of 27, and I index of 10 with 45. He also serves as an associate editor of Springer Journal of Control, Automation, and Electrical Systems and reviews for several leading SCI journals and competitive exams. Dr. Mikili has successfully completed major funded projects over 86 lakhs, including an early career research award from the Government of India. He has guided four PhD scholars and is currently supervising nine more. Actively involved in academic leadership, he has also organized multiple GIAN initiatives, ATAL FDPs, and STTPs, and delivered more than 125 invited keynote talks. At NIT Goa, he has held a key administrative positions such as HOD of IEEE, Dean of the Students' Welfare, Associate Dean of the Faculty Welfare, and Chief Warden, and currently serves on the Board of the Governors while leading the EEE department. We heartily welcome you, sir.
Thank you, ma'am. Thank you.
Thank you, sir. Over to you.
Welcome, sir.
Sorry, sir, could not hear.
Yeah, I just welcome, sir.
Yeah, thank you. Thank you, sir.
Welcome, Dr. Mikili, sir.
Thank you, ma'am. Thank you.
Yeah.
So, good evening, one and all. First
Good
and
evening.
foremost, I would like to thank the entire organizing committee of this 6 days ATAL FDP, especially Ashok Ramana College institutions, even management, as well as the entire departmental faculty members also, and even student volunteers. So without delay, so we'll start today's session. Is my screen visible, ma'am?
No, sir, your screen is not
Not
visible.
yet, sir.
1
Please
minute.
share the screen.
Okay, sorry. I will
Okay.
share entire screen. Now I'm sharing it. Is it okay now? Is it okay now?
Hi.
Yes, sir.
Yes.
Okay.
Yes.
So I welcome you for this ninth session. I hope. So today we are going to discuss
Your
about
voice is
role
cutting, sir.
of
Excuse me, sir.
IoT in industrial automation with
Sir, sorry to interrupt you, but your voice is not audible clearly.
some case studies I'm going to take. It is nothing but IoT, industrial Internet of Things. Okay. So before going to that, I will give you just basic.
Sir, sorry to interrupt you. Your voice is cutting, sir.
Ma'am, one second. 1 second. Now is it okay?
Yes, sir. Clearly audible.
Yes.
Sure, no? Yeah, thank you.
Yes, sir.
Yes,
Yes.
interruption. Please let me know. I am outside actually.
Sir, the signal strength is varying actually.
Sense.
Uh, there is an interruption in. There is no continuous audio.
It's not audible now.
No, no, sir.
Hello, Dr. Mikili, sir. You are not audible.
Madam, is it okay? Am I audible now? Hello, am I audible now?
Yes, audible.
Oh, okay, sorry. Okay, so today we are going to see role of IoT in industrial automation with some case studies. Okay, so especially IoT in industrial automation we are going to see. Okay, so first we'll try to see. I will connect with what is the role of industrial Internet of Things in the next generation manufacturing, okay, towards industry 4.0 mainly. Okay, so before going to that, we should understand what is industry 4.0. Okay, so industry 4.0 already other people might have discussed with you. Just let me give you basic detail. Industry 4.0 is nothing but the fourth industry revolution. Okay, that means we are having three more revolutions are there. This is the fourth industrial revolution where we are considering Internet of Things, artificial intelligence, robotics, sir, sorry, am I audible now?
You are audible, sir.
Sorry, sir. I'm outside actually.
Okay. Okay, okay.
Okay, shall I start? Is it okay?
Yes, is it okay, sir?
Okay. Sorry. See, today we are going to see role of IoT in industrial automation with some case studies we are going to see. Fine. So here, so what I meant to tell you is, so before going to the industry OT or IIoT, so I want to tell you about Industry 4.0 is nothing but fourth industrial revolution. Evaluations were there, Industry 1.0, 2.0, 3.0, and now what we are having is Industry 4.0. What we are considering here? We are considering Internet of Things, artificial intelligence, robotics, even cloud computing we are considering, and big data convergence we are doing. For what reason? To create the smart and autonomous factories. Our motto is to create the smart and autonomous factories. For that one, we are using all these things. Okay. Now, when it comes to the Internet of Things in industrial automation is nothing but it is called as industrial IoT. What it is? IIoT. It integrates again sensors will be there, actuators we are considering in industry. No, in industry Internet of Things we are considering sensors, actuators, data analytics we are considering. For what reason? To enhance industrial processes. How to convert or how to create smart factories. So industry processes, for industry processing, we are considering sensors, activators, communication networks, and data analytics to enhance the industrial process. We are using IIoT. Okay. Now, by connecting machines, equipment, or systems in real time, what we are doing, IoT will be enabling smarter decision thinking rather than normal decision thinking. Smarter decision thinking it will give predictive maintenance. That means, suppose in future what will happen with these conditions. So it is going to give prior only some alarming it is going to give, predictive maintenance, energy optimization it will is going to do, operational efficiency it is going to give. We will discuss all these things. Okay. By connecting machines and time is IoT what is giving smarter decision making we are getting, predictive maintenance we are getting, energy optimization and efficiency we are getting. Okay. So together what we are doing, we are transforming traditional manufacturing into a smart manufacturing which includes flexible, efficient and predictive systems. Okay. We are transforming traditional manufacturing into smart manufacturing. Okay. Now let us go little bit details about how the industry 1.0, 2.0, 3.0 was there. Just in industry 1.4, how the evaluation was happened, where the IoT fits. I'm trying to explain. Industry 1.0, the mechanization of use of water and steam power it was used. Initial days in 1700s, initially they have considered steam power. Industry 1.0. When it started also I will give you. Industry 2.0 of electric lines. What they have considered in industries, they have considered steam power turbines, they have designed the steam power. Robotics they have used. In industry 3.0, little bit automation they have included with the help of computers, PLCs and robotics. Here people have considered SCADA system, supervisory controlling and data acquisition. That means we are using a little bit of intelligent machines. They started using computers, PLCs, robotics they have considered 3.0. Now industry 4.0, smart factories we are going to consider. This is the present. Smart factories, how we are getting? Earlier computers were there. Now in the computers we are considering Internet of Things. In the computers, AI we are including. In the computers we are including cyber physical systems. Is it clear? 3.0 just consists of computers, PLCs, robotics. 4.0, we are considering the factories, converting factories into smart factories with IoT technology, AI, cyber physical systems, even cyber security issues, we are including. Fine. Now, where IoT fits, when it has started, if you see, Industry 1.0, 1780s, it was there. As I told you, steam power as well as water turbines, they have considered the mechanization. That time, there is no IoT, isn't it? Second Industry 2.0, it was started in 18th century, 1870s. From 1.0 to 2.0, Industry 1.0 to 2.0, 120 years to convert steam power turbine normal ones to basic electric circuits, mass production of electricity transmission lines. So that time also we were not having 18th century, we are not having IoT. Okay. Now, from second Industry 2.0 to 3.0, how many years it took? Almost say 30 and here 70, 100 years, 90 to 100 years. Now here, people have considered electronics, computers, PLCs, automation is done with robotics, PLCs they have considered. Now, early computer-based monitoring was done. But complete IoT when we have considered in Industry 4.0, now after that, quickly 2000 onwards, within 30 years. So what we have done? In that, we have used 20th century words, IoTs, cyber physical systems, AI, cloud computing we started using. Now, the core enabler of connectivity, smart sensing, automation, it is started in Industry 4.0. Industry 4.0 is now it is considered. Now, if I see the how the growth is, if you consider 17th century, it is just the basic standalone devices people started with the fire, other things normal way. Now, 1784, steam power turbines and water turbines people have considered. It's 1784. Now, 18th century, Industry 2.4, then they have considered assembly of electrical lines. Then 1970s, automation. 2020 onwards, we have considered cyber physical system with Internet of Things. Now you see the persons with Internet of Things. Okay, humans and machines are integrating now. Is it clear? So like this, the improvement is started from basic of steam power to electric technology. From there, in the computer technology, we have included what? IoT, cyber physical computing. This is the process how it is improved. Now, let us see. Initially, Industry 1.0, basic steam turbines of thermal power plants were there. Then Industry 2.0, then we have considered electrification. 3.0, with the help of robotics, that manufacturing is started. Now Industry 4.0, you observe wireless sensor networks, cloud computing, IoT, AI, we are integrating with the machines. Is it clear? We are integrating with the machines. Initially, normal steam turbines. Then we have considered Industry 2.0 with electrification. Robot control. Now, completely process control. Completely digital in system. This is what 4.0. Now, the strategic shift to Industry 4.0, what happened? Next generation. Now, the manufacturing is producing the items or goods at a larger scale. People are not now producing, they are thinking customized goods, sustainable products they are going to consider. Try to understand. Previously, if you have some particular equipment or component item, it was okay. But now people want customized products. Watch, smartwatches. They're having smartwatches. Isn't it at home now? you are having automatic lighting switches are there. So we are producing smart and customized and sustainable manufacturing in the industry 4.0. Earlier it was just goods at a larger scale, but now we are producing the smart and customized and sustainable products we are considering. So past, if you consider, efficiency was gained by mechanization, electrification, later started automation, but present 4.0 integrates digital ecosystems where machines talk to the machines, data drives every decision will be taken by data centric. Okay, smart meters we are considering, artificial intelligence we are including in the machines. So as I told you, entire thing is digitalized. Okay, so now in the present system we are integrating digital ecosystems in the products or in the systems, so that machines will talk to the machines and data drives every decision. The future is what? Industry 5.0. The factory is evolving into autonomous, adaptable of learning, self-optimizing in real time. Okay, so let us see illustration of industry 4.0 technologies. What we are having, just list out, we will see, then we will go to the main topic. Okay, if you see the industry 4.0 technologies, what we are having is, we are having big data analytics is there, artificial intelligence is there, authentication and fault detection is there, augmented reality, virtual reality will be there, manufacturing and industrial IoT and customer IoT is there. Customer IoT is different, industrial IoT is different. Cloud computing we are having, autonomous robots are there, and human machine interaction is there. In industry 4.0, we are having various sectors are there. One is takes about big data analytics. One talks about AI in all the sectors. Authentication and fault detection in all the sectors. Augmented reality, if you take a computer vision, other things, augmented reality and virtual reality is there. And if you take, coming to the IoT, customer IoT is there, industrial IoT is there, cloud computing is there, edge computing is there, even now fog detection methods are there. Okay, and we are having autonomous robots are there, cobots are there, and human machine interaction also available. Okay, now we go one by one. Core features of industry 4.0 in manufacturing we will see. Okay, smart factories, how we will convert it into smart factories. First slide I told you, we are converting the entire, we are converting entire industry 4.0. We are creating smart and autonomous factories we are going to create with the help of IoT, AI, robotics and cloud computing, isn't it? So now let us consider. Now if you see smart factories, what we are doing the smartness, machines we are using smart machines, sensors we are considering, humans communicate in real time, machines we can communicate with the machines, humans can communicate with the machines through the IoT, through AI. Okay, so we are making smart factories in 4.0. Second one, cyber physical systems we are considering. What is meant by cyber physical system? We are integration of physical systems with digital system. Now, for this example, I will give you. Earlier, we are having normal smart grid is there. Normal grid is there. Now, in each and every substation, if you keep a smart meter, you are using a communication protocol. Earlier, if I want to collect the data from one substation, you used to call and you used to get the data. How much power is generated, how much load is there, how much remaining. But now, if you install smart meters, if you install communication protocols in each substation, I can automatically get the data from each substation, how much generation, how much demand, how much can be injected. That means we are injecting digital systems with the physical machines so that to acquire the data or to make it become smarter. So cyber physical systems in the sense, we are integration of physical machines with the digital systems, digitalization of existing system we are doing. Okay. Now, next one. When it comes to Internet of Things, two types are there. One is Internet of Things, normal customer. Second one is industrial. So in the Internet of Things, what you are using, sensors we are adding into the network and exchange the data across the equipments we are using. Internet of Things in the sense, we are same adding the sensors and we are adding communication protocol system and we are exchanging the data across the equipment. I will give more analysis. Now, big data analytics, what you are doing? Data driven insight process. What does it mean? For optimization and decision making, we are having from the plant, we are having huge amount of data is you have taken. Okay, you take smart grid, huge amount of data from transmission line, generation, from distribution you got. So at what time base load is there? At what time peak load is there? At what time generation is more? At what time load is high? Okay. So each and every data you can analyze. Suppose if you take another industry, okay, suppose solar system you take. So at what time solar power is high, at what time solar power is low. If you integrate wind with the system, at what time wind power is high, at what time wind power is low. So that means if you integrate either renewable energy into the grid or if you integrate any batteries with the grid, so this data is there, you are doing the analysis, process optimization and decision making you are taking. When, what to operate, how to operate. So when data is available, you are doing the big data. On the big data, you are doing the analysis for optimizing the networks, for taking the decision making. Is available previously, nothing was done. Data was there. Now what people are doing, with the help of IoT, we are collecting the data, we are optimizing the network, we are controlling the network. Before the fault happens, we are predicting and protecting the system. Earlier, even though data is available, person has to call and collect the data. Before he collects the data, damage was happened, the fault was happened, then the power was gone. Now, before the system gets the fault, any unwanted signals are there, some data is high and more power is there, then you are collecting the data, predicting before only, you are protecting the system. Okay. Now, cloud and edge computing. Here you are doing the remote storage we are doing. Cloud, no, we are storing the data. Most of the people knows in mobile how it is. Similarly, if you want to store the data, cloud computing we can do, even edge computing can be done. It is a faster processing and scalable. Intelligent robots, considering we are having autonomous robots are there, which will work intelligently by taking the inputs from the humans or by taking by program wise it will work. So there are intelligent robots which will work along with the humans. These are called autonomous robots. Okay, based on the instructions given by the system or the person. Additive manufacturing. What does it mean? 3D printings are there. This is the product, whatever you want, that can be 3D printing can be done. Digital twin application. Okay, so we are having so much of testing can be done. Virtual replicas can of the can be done. Many aspects are in 4.0. Now, today our main concept is IoT versus IIoT. Okay, so let me go there. Now, so one topic I'm taking, what is that? Internet of Things. My today's topic is on Internet of Things. So here we have two types of IoTs are there. One is consumer IoT, second one is industrial IoT. Consumer in the sense customer level IoT, personal level. Consumer level IoT we are having, industrial IoT is there. If you consider Internet of Things for personal level, that is consumer IoT. If you use Internet of Things in industrial processes, it is industrial IoT. That's simple. If you use Internet of Things for personal use, for human beings, that is consumer IoT. Whereas if you use Internet of Things for industrial level, that is industry IoT. What we are having consumer level. Smartwatches, I told you. We are having smartwatches are there. Okay. We are having low energy protocols are there, limited infrastructures are there, home devices. Suppose at home, no, I told you, power now with on off switch are there, clapping is there, even movement automatically turn on is there. If you go to washroom, flush will happen. Even it private security, personal data security, consumer friendly. So we are having consumer IoTs, different areas it is there. It is mainly for the personals. When it comes to the industrial IoT, we have industrial applications will be there, operational data in the industries will be there, cyber security issues in the industries will be there, complex machinery data, efficient infrastructure, fast communication comes under industry. Now, detail we will see. When it comes to the Internet of Things, what it is simply a network of things consisting of software, sensors, and similar technologies to enable the connect with the internet to exchange data, information, and instructions. We are exchanging the data, we are exchanging the information, we are exchanging the instructions with the help of software, sensors, and similar data. Where we are exchanging the data. These devices offer consumer-friendly solutions, which are used for monitor, control, and track. Smartphones you take, a smartwatches you take. Smartwatches, it measures how much blood pressure is there, how much SpO2 is there, how much kilometers you walked. Okay, entire data is tracked. This is nothing but Internet of example. Okay, now health monitoring we are doing domestic. The difference between IoT and IoT is industrial solution in which Internet of Things are integrated with the industry settings. Okay, to work proficiently, operational efficiency for the business, mainly used for supply chains, factories, power plants. We are considering. Okay, so it is used mainly to save the time, to reduce the additional expenses, to get accurate analysis. We are using IoT in industries. Why we are using? To get accurate analysis, to save the time, to reduce the expenses. Now, without delay, let me go IoT applications. IoT applications is Internet of Things. Okay, where we are having applications is healthcare, smartphones, transportation. Now, patient monitoring we are doing, wearable health devices we are having, automatic transfer of health updates to doctors, it is happening, real-time feedback we are getting, and analysis we are getting. Remotely patient we are there monitoring or not. Earlier we need to go to hospital only. Now through online also we are monitoring patient case sheets. Wearable health devices are there. Automatic transfer of health, real is there. Automatically the data, if it feeds, then automatically person will get the in the mobile, he will get the update. Real-time feedbacks we can get. Okay, smart homes if you take, smart thermostats are there, smart lighting at home is there, smart appliances are there. Even your fridge will have a smart appliance. Through the phone, you can reduce or increase the temperature. You are having security systems are there. Remotely, you can connect with a smartphone. Transportation, if you see, suppose future is PV integrated EV charging station. Even fuel is available or not, GPS, through the GPS you are connecting. Transportation when you are traveling, through the GPS you are connecting, there also IoT is used. How much fitness is there we are checking. That means mainly Internet of Things is healthcare, consumer level, health we are checking. Smart homes level we are checking. Transportation, when you're going GPS, other things we are checking. Even fuel where it is available, we are checking. Where the hotels are checking, restaurants where it is. That means all customer friendly related issues, everything. Wherever you are using IoT, these are the IoT applications, customer level IoT. Okay. Now let me go industrial IoT. The main topic is industrial IoT. When it comes to industrial IoT, manufacturing, smart grid we are having, smart city we are having, smart communications, smart car, robotics, industrial. So many industries we are using industrial IoT, Internet of Things we are using, manufacturing we are using, smart grid we are using industrial IoT, smart cities we are using, communications we are using, in car we are using, car also one of the components. In robotics also we are using. One by one we will see. So in automation we are considering automation. That means to get accurate, efficient and productivity, we are using automation. Supply chain advancement, tracking of cargoes. Suppose in the warehouse where the stock is, factories inventory management we are checking. Okay, so even energy handling, monitoring and optimizing of material in the factories for cost effective steps. Okay, even predictive maintenance also we are doing before only problem when it happens, that we are checking. That means what does it know? Okay, so practical applications in IoT is, first one is predictive analysis for maintenance we are doing. Okay, new functionalities HMI we are checking, industrial remote access we are checking. Okay, then optimize industrial robotics we are checking, quality control we are checking, plant safety improvement. One by one, let me tell you. Predictive precision. What is meant by predictive precision? Suppose if you consider IoT in the industry, what it will do? We are using the advanced sensors in the industries, isn't it? Now, if you use advanced sensors in the industries, what it will give? It will give complete information about the machine, how it is working. Continuously, it will track about the performance. It gives the predictive analysis. That means it will identify the issues before they become major. It will avoid the disruptions. It will avoid disruptions. Understood? It will avoid the disruptions and prolonging machine lifespan. It will increase the lifespan of the machines. How? Suppose if you identify before the machine get damaged, now what will happen? The lifespan will increase. It will manage the maintenance of expenses effectively. That means when you consider the settings, okay, so it is going to give you understanding about the entire machines it is giving, continuously tracking the performance of the system, so that what it will do, it will give complete analysis like, oh, it is going to give the major problem. So this is the data previously, last year data is this, last month data is this, last week data is this week data is this. So there is a fluctuation, there is an issue, okay, better out predictive precision it will give based on the data what it is having already previously. Now, streamlining supply chains, what does it mean? Suppose if you consider in the industrial Internet of Things, okay, it impact the entire supply chain. What does it mean? It does the real-time tracking. It does the real-time tracking of the flow of material, work progress, how much work is finished. That means indirectly it sees what products are available, what is the work is going on, how much work is finished, and it gives you efficient and effective, responsible inputs and feedbacks will give it to you. That means half of your work will be done by this only. Okay, it gives you input. Yes, this much is available. Okay, if you give the tags total, every material, if you give the tag, what it will happen? This much material is done, this much material is available, this much work is completed, this much work is remaining. Our entire data you will get, you will understand streamlining of the material, flow of material, process and the work progress. So that means it will become efficient and cost effective. It will happen. And energy intelligence, what does it mean? Okay, so By considering the industrial IoT, there is you can reduce the expenses, sustainability objectives will increase. Not only that, quality assurance will also increase. And one more thing, visibility and optimization can be done. Suppose if you forget some components you have purchased, you may forget, but if you give tagging to all the components which you purchased, which is available in the system, so if you have a database, then what will happen? So from particular database to raw materials to all the finished products, it tries to give the complete transparency. It will give you, that means complete details about raw material, complete data about the products, and it gives optimal utilization of resources can be done. Sometimes what will happen, we may buy extra components, we may buy extra devices sometimes. So but here what is happening is, so we are having the possibility of, okay, optimization is happening. So then what we are having is, next one is remote control and uh, decision can be done, safety will be happening. Okay, so now what is there? So combining industrial IoT and automation, okay, is giving greatest advantage for industrial aiming at efficiency and innovation. Fine. So now, so when you consider the mainly, if you have an Internet of Things and industrial Internet of Things, so when you focus, when you consider normal IoT will gives you consumer friendly and regular devices, whereas industrial IoT will gives you, it focus on complex systems and industry applications. Try to understand the main focus of IoT customer level IoT is, it is basically depends upon the customer friendly and regular devices. But when it comes to the industrial IoT, it works on complex systems, it works on industrial applications. Okay. Now, when it comes to data, Internet of Things deals with personal data. Internet of Things deals with personal data, lifestyle data, whereas industrial Internet of Things will deals with data and performance of the entire industry will be there. Here only you're having personal data in the customer level, but here be available here. Okay, so here our objective in the customer level Internet of Things is, it improves the convenience and the user experience. Particular user wise, it improves the convenience of the user. But whereas industry Internet of Things, the complete industry's efficiency is improved, productivity is improved, and safety is improved. Understood? So that efficiency will be improved. But in the normal customer level, only convenience is improved. Okay. When it comes to security, personal data will be secured with the help of Internet of Things in the customer IoT. But in IIoT, operational and cyber security issues will be taken care. So when you consider the device difficulty also, here we are considering home level and wearable level. 7:30. Okay. And when it consider so when we consider the device level Internet of Things, so here we are having either home gadgets and wearables will be there in the customer level, whereas customer IoTs, whereas industrial IoT, when you consider, we are having complex machinery, automation and sensors we are considering in the throughout the network. Fine. So even when you consider infrastructures, since customer level single one, so it is a limited infrastructure, relatively smaller scale will be there. But when you consider IIoT, we are having, since higher infrastructure will be there, it will be in the larger scale. Okay. So when you consider customer level or normal IoTs, so we are using connectivity through Wi-Fi, Bluetooth, and low energy protocols is sufficient. But if you want to consider industry IoT, you need to have cloud computing, edge computing, and communication protocols will be mandatory. So as I told you, some examples are customer level is smart lighting, cameras, smart watches. These are the appliances. But when it comes to the industry level IoT, so autonomous robotics, cyber security, okay, and there are several things are there in the IIoT. Fine. So the benefits of here when you see, so the focus of IoT normal one is consumer level, personal data, only convenience is improved, personal data security is happening, only wearables and home gadgets are there, limited infrastructure, only we are using Wi-Fi, Bluetooth and low levels. So examples are smart lighting and cameras, watches and appliances. When it comes to IoT, it works on the complex systems, industry level applications. So to improve the efficiency of industry, we are productivity, scalability we are doing, and safety and cyber security operations we are doing. It works on the complex machinery as well as automation we are considering. Okay, and here rather than Wi-Fi circuit, we are using edge computing and cyber security issues. Okay, then here advantages are, since we are using for the complex systems, since we are using edge computing and communication protocols, since we are using cybersecurity and robotics we are including, so here advantage is the quality is improved, quality of the industry. So before Internet of Things in the industry, we were not having the efficient operational issues, cybersecurity issues, anything is there, or maybe live monitoring. These are all are not possible. Since in the industry, when you add industrial IoT, the quality is definitely improved, the cost is reduced, enhanced worker safety is improved, and operational efficiency is improved. Customer experience is better, human errors are reduced. Why? Everything will be taken care by the computer. And the predictive management is good. Asset traceability is very high. Why asset traceability is very high? Since we are using all the systems with the tag numbers, all the systems data entry you are doing. So it is easy for you to get the data from the data center. Okay, so the predictability or predictive management is extremely good, human error is reduced, and better customer experience we are getting, operational efficiency is very good, and quality is very high. Assets also you are able to trace, assets also you are able to trace from material to from the products, and the cost is reduced. So that's why when you consider Internet of Things commercial level and industrial level, so that's why I told you commercial level, when you go hospital, healthcare, that retails, when we consider. Okay, even if you consider hospitals, no, hospitality in the sense energy efficiency, occupancy monitoring, okay, customer service scoring, these things. But when it comes to healthcare, the patient monitoring, virtual care, how wellness is there, or any issues are there, online only people are giving the suggestion. Now retail, if you take retail market commercial level, so if you stores, if you go, no, even people are giving store promotions through online, shopper analytics they are giving, ordering and payment is online, people are taking, even people are having vending machines are there. For everything small to larger scale, when you consider, we are having the commercial Internet of Things. What we are having is, so we are having healthcare, in the retails we are having. So when you consider industry level, so we are having mining and oil and gas we are considering industry application, utilities we are considering industry application, smart cities we are considering, utility in the sense smart grid. Okay, smart cities we are considering, even building also we are considering. Now when you consider manufacturing, okay, manufacture, any company you take, manufacturing company, it can be manufacturing robotics, manufacturing of processors, manufacturing of sensors, or manufacturing of any of the items, any manufacturing company you consider, every company will have some availability of equipment is required, product is completed or not required, and quality monitoring is required, is it efficiently working or not required, and the packing is proper, is prevent and predict the maintenance is required, supply chain are also not required. So in the manufacturing process, from the raw material to till final product. How many materials are there? Finally, how many products are happening? How the process is happening? One by one, any mistake is there. So entire thing is in the hands of industry robotic. Now, if you go to mining or oil and natural gas, equipment they will monitor. They will check the assets, production monitoring. That means how much amount of quantity of oil they have extracted, how much amount of gas they have extracted, how much amount of mining, no, how much they have extracted, what are working, okay, how much assets they have tracked, 4-day analysis. The entire data will be available. Now, if you take even agricultural environment, they will check the monitor. That means okay, now monsoon is there, or summer is there, or the climate wise, which climate is there, irrigation, which crop has to be done, okay, the product is there, okay, what type of issues are there, and what pesticide can be given, how the water management should be integrate, even solar integrated systems. So when to do now, automation people can be done. Even if you take smart grid, now previously normal grid, if you consider, we used to collect the data, as I told you, from each and from generation, from the transmission, and from the distribution. People used to collect the data. That is through telephonic operation. But now, since the people have integrated smart meters with the electrical network, each and every field, you can extract the data from each and every substation. So now utilities are equipped with the smart meters, which includes phase measurement units. Now, grid management can be done. Now, earlier we were not having renewable energy integrated sources, but now what we are having renewable energy integrated sources. We are having PVs, we are having wind, and even we are having batteries. So PVs can be integrated, wind can be integrated, wind energy mills, and we are having batteries can be integrated. Now, along with the smart meters, some DGs we are integrating. Okay, so when to integrate, what to integrate. Now, grid to system, when to it should be, or when we need to connect with the online grid, when it should work with the offline grid. Okay, so entire management can be done in smart grid, can be done. And even when you consider even plants, when you consider even the waste management, power management, energy management, power line management, everything can be done with the utilities. Now, if you take the smart cities, how the parking is happening, how the environment, road and traffic, transportation, security. So in all the fields, it can be also, it can be done. Now, when you see, I told you already, so when you consider sector wise, so when automotive industry, when you're considering, so digital twins optimize the car assembly lines. So IoT sensors improve the engine testing. Now, so people have considered, okay, so and improve the defect detection by 90%. Actually, the BMWs, they have used AI technology in quality inspection. Okay, and they have considered defect detection by 90%. They have considered the defects. That means by considering in the automotive digital twins, by they have identified the 90% of defects detection they have done. Okay, now even they have considered aerospace. If you take, they have considered additive manufacturing reduces the weight of the particular parts. If you headache or no problem. And in the aerospace, the predictive maintenance, which ensures the safety of the aircraft also. Okay, so now here what they have used, 3D printed nozzles, so that 25% it is lighter, 5 times the durable. Okay, and even they have considered healthcare and pharma. So what they have considered, the precision manufacturing of medical devices and smart production of personalized drugs they have taken. So here what they have considered is, the example is, everyone knows, during the COVID time, they have taken Pfizer, the vaccination. Now, when you take heavy industry, steel, even oil and chemical, the people are considering energy optimization. That means to reduce the risks, to increase the energy optimization, people are considering IoT sensors. Example is Tata Steel. They have used smart plant. They have reduced downtime by 20% with predictive analytics. Okay, these are the things which already implemented by the people, or which is adapted by the people. Okay, for consumers, good and electronics if they want, so even people have considered. Now, when you consider cyber physical systems, when you want to integrate digital systems with the machines, physical systems, so what they are doing, integration of machine with the digital system they have done. So then the self-adjusting of conveyor belt they have done. Now, industry IoT, they have connected sensors and devices, smart meter monitoring is happened. When you consider big data and analytics, they have done analyzing the entire have done. Okay, so the predictive defect detection was happened. How it is happened? So they have calculated the previous data and the present data. They have analyzed the defects detection was done. And when it comes to AI also, decision making was taken. Okay, for quality. And cloud computing also, central and local processing it was done. Digital twins also, as I told you, simulations were happened. So in each and every field, so there are the improvements are there. So now directly I will go there. Okay, so rather than this, some case studies, if you take, even Siemens company has taken, the challenge was high defect rates in traditional manual production they have taken. Okay, now they have included IoT sensors, AI, robotics. By including that, 75% automated, defect increased. Same Bosch company, okay, connected with the industry IoT, frequent downtime was happened in the assembly lines. Okay, now with IoT AI-based predictive maintenance, now downtime is reduced and productivity is significantly improved. Same, I told you already, BMW Group. So they felt that challenge was complex vehicle assembly and customization demand was there. They used digital twin simulation. Okay, with that, design to market cycle reduce, greater product flexibility improve. Okay, similarly, the Apple suppliers, they use Foxbots and they improved the reduce the labor dependency and process consistency is improved. So GE also I told you. So here the fuel efficiencies improved and predictive maintenance millions they have saved annually. So when you take like this, what will happen? So in the Siemens company, since they have used smart factory with IoT and AI robotics, efficiencies huge it is improved and defects are reduced. Same Bosch company, when they have considered IoT and AI, downtime is reduced. So, and when you consider even BMW Group, 30% faster designs is happened. So, and when you consider GE, the fuel efficiency is reduced and what will happen? Downtime is reduced. Okay. So these are the applications which we consider. Now, the benefits and challenges of IoT we will see. What is the higher efficiency is there, reduced downtime is there, predictive maintenance so that cost is reduced, real-time visibility is happening, process control we are doing, safer workplace and regulatory compliance we are doing, and the mass customization and flexible product supports the green manufacturing we have done. Now, these are all our advantages, whereas there are some challenges are there. What is that? Initial investment is very high. And since you are using Internet of Things, cybersecurity issues, data privacy risks are there. Now, when you are integrating the systems, there is interoperability issues are there. Okay. Still, there is a skill gaps are there. The skilled persons you need to consider. Okay. And one more thing, handling large that is also one issue. And one more problem is lack of global standards. Lack of global standards. These are all the issues we are facing. Even though we are having efficiency high, downtime reduced, predictive maintenance is there, real-time visibility is high, workplace safer and regulatory compliance is there, cost in BMW 4.0 integration, like integration of IoT, AI, robotics, everything they have considered in the Bosch companies, and even Schneider Electric, smart energy systems, they're using green manufacturing. Okay. Now, so when we consider the IoT is redefining the industry automation by shifting industries from reactive to predictive and autonomous systems. So while challenges like cybersecurity issues are there, higher cost is there, legacy integration is there, but still IoT creates immense opportunities in the smart factories, immense opportunities in the digital twins, AI powered optimization is there, sustainable operation is there. See, these are all the things are what Siemens know. Productivity 99% increase, 14 times growth is increased. BMW, I told you, no, production time is reduced 30%. That means 30, suppose if you need 100 hours, within 70 hours they could able to reach their target. That means remaining 30 hours they can get better. No, now even Amazon, they used IoT robots and RFID tracking. Efficiencies boost is happened. Faster delivery also they are doing. Oil and natural gas they are using. So what I mean to say, even Tata Steel they are using. So every company they are already considering Internet of Things industries, and they are seeing the product quality is increasing, time is reducing, efficiency is high, time is reducing, and fuel efficiency is high, downtime is reducing. So these many advantages are there. Even though we are having cybersecurity privacy issues, initial cost is high, and integration issues are there, but still, due to immense opportunities in the smart factories, digital twins, AI powered optimization, sustainable operations, it is giving very good response for the IIoT. Now, as I said, the case studies prove that IoT leads to higher efficiency, cost saving, better safety, global competitiveness is there, and industrial IoT is the backbone for Industry 4.0 and 5.0 and so on. Without industrial IoT, Industry 4.0 is nothing. Why? Whatever you want to have, it may be in the healthcare, or maybe it may be in the electronics, it may be in the smart grid, smart home, smart utility. Where not? If you don't have industry IoT in the industry, industrial IoT not there, we are, you can't say Industry 4.0 at all. So Industry 4.0, the main backbone is IIoT only. Okay. So due to higher efficiency, cost savings. Okay. Now let us see IoT in the next generation manufacturing, how it is influencing. We will try to see. Okay. Already I discussed. Now, if you see overall Internet of Things. Okay. Now, traffic management is there. Automatically, we can do the traffic management with the Internet of Things. That means now people are using sensors, no? 20 seconds if I keep, or 40 seconds if I keep, automatically it is on and happening without that. Now, if I want density wise, suppose in one side more traffic is there, other side less traffic is there. Even density wise traffic management can be done. Their Internet of Things can be applied. Even Personal area network also Internet of Things can be done. Mining Internet of Things they are doing. Even in the food, parcelings, other things, automobiles, electronics, are having industrial Internet of Things are available. Even electrical factories, not even electrical, chemical, mechanical, whatnot. All the companies, industries, people are using nowadays industrial Internet of Things people are considering. That's why I have shown you few examples related to one is automotive mobile industry, BMW I have shown. One is related to Amazon, that is real-time. Other things I have shown, Bosch I have shown, and even I have shown even oil and natural gas, Tata Steel I have shown. So different companies we are having. So when we consider this, so what I mean to say is, so IIoT and Industry 4.0, if you consider as a two terms, okay. So now here, what my intention to say is, okay. So full potential of IIoT can be achieved by midware. What is that? Middle fog is there. No, this is the midware. This is midware. Okay. So it will handle the resources and communication networks. This midware network will handle what? Will handle both the things. What is that? Communication of underlying nodes. It provides required local processing. Okay. Different varieties of things are there. We are having sensors are there. Somewhere we will use the sensors. Okay. Wi-Fi circuits we are using. Okay. Wi-Fi BLE. Here we are using transportation, 4G, having other industries are there. So, and here be robots are there, it can be actuators are there, it can be machines can be there, it can be sensors are there, it can be devices are there. All the devices, all the sensors, activators, machines, anything you consider, everything will be controlled by what? Internet of Things only. Am I clear? We can have n number of companies. It can be robot related. It can be activator. It can be machines, maybe industries. It can be sensors, devices. All are controlled through Internet of Things only. How we are controlling? Either if you take an industry, you are doing data analytics. You are doing management system. Suppose this industry is related to smart grid, you consider. Then energy management we will do. And there is data related to that one you will store. And suppose predictive management, if I want to do, you will do the data analytics also. Suppose if I consider activators or robots, if I consider how it is working, we will see. If I consider some devices, even that data will be stored, even it will be stored in the cloud computing, entire data. Okay, now, as I told you, suppose if you consider a smart grid I told you last time already, we are having through hydro we can generate the power, through PV I can generate the power, through the wind I can generate the power, through biomass I can generate power, through biogas is there, even I can say that through thermal, through hydro, through solar, through wind, through geothermal, through maybe geothermal, even this one is biomass is there. Different ways we are generating the power. Previously, we used to depend on mostly thermal, but nowadays we are depending mainly on renewable energy. Okay. Now, if I want to integrate everything with the grid, okay, previously we used to depend on only one thing, thermal, from one place to other place, it used to transmit. Now, what happened? Throughout the network, we are having transmission lines are there. Now, residential level, we are having smart homes are there, smart meters we are giving, advancing infrastructure we are giving. Even this power line is connected to commercial subways. These power lines are connected to industries. This power line is connected to EVs and EV chargings. Now, residential, power lines are connected to commercial, Power lines are connected to industrial. Even power lines are connected to EV PV charging. Place one customer, one sort of data I need to give. Now, if you have a smart board, everything, this data also need to be stored. Through SDN network, data is stored. Here, what type of commercial loads are there, that data will be stored here. Industrial loads, what is required, data is stored in the SDN network. Then accordingly, you are integrating. So my meaning is, the Internet of Things can be connected to any of the application, either can be smart grid or machines, sensors, devices, activators, robots, anywhere can be applied. So even suppose during morning time, I no need to integrate, this entire PV power will be stored in the battery. Even wind power, less load is there, it can be stored in the battery. Whenever requirement is there in the evening time, from the battery it can be taken. So which will do that? This SDN network will act as a middleware. Okay. Now, even if I want to do interoperability issues, even taxonomies are there. Now, what we will do, we are having program interoperability will be there, platform conceptual interoperability issues are there, technical interoperability issues will be there, then syntax interoperability issues are there, semantic interoperability issues are there. What does it mean? What does it mean? Now, technically, if I take any of the system, okay, data exchange you are doing, end-to-end communication you are doing, what information is there, okay, which technology you are using, so one-to-one data is transferred or not, how it is transferred. Now, conceptual, if I take, so which type of network is there, what type of connectivity is there, is it Wi-Fi, is it transmission or distribution, which network it is considered, platform, it is inter-domain or intra-domain. In the sense, it is data format is required, data structure, which one is required, which rule they are doing, either encoding are doing, are you decoding are you doing, which way it is required. And semantic in the sense, what type of models you are considering. Okay, so we are having either device level interoperability issues are there, technical level interoperability issues are there, and data collection wise interoperability issues are there, programming wise interoperability issues will be there, even sharing the data interoperability issues are there. So everything will be connected in a proper manner. Okay, not only the devices, even services, platforms, gateways, apps, all to be connected properly. Understood? There are common services can be there, which are given to previously I have shown. Residential load I'm connecting, commercial load, industrial load, even public corridor I'm connecting. So I'm having different customers are there. Every customer I'm giving the data or power I'm giving. Here also, which service to whom I have to give, which platform it is connected, what is the gateway. So everything you have to check properly. Okay. So we are having, when you consider overview wise, we, as I told you, technical level, syntactic, semantic, programmatic, platform, conceptual, different interoperability issues are there. Even initially, if you take service provider, if you take, and data is stored in the cloud computing and edge computing, middleware, if you take, gateway will be there, and consumer level IT applications are there. Even we are having industry there, which design is required, which products are there, what need to be maintained, what type of systems we are having, industry level, what type of customization to be done. Okay, so when customer level, if you take consumer level, what type of issues are there? When you take any of the consumer level applications, what type of issues are there? When your data is stored in the cloud, what type of issues are there? When gateway you are connecting, which issues are there? So overall, you are having, as I have shown, industry applications, smart grid applications we are having smart utilities are there, smart home is available, even customer level applications are there, even we do have so many middle grids are there. So you have to integrate with each and everything. So what I mean to say is, Even when you consider traditional grids also, initially we were having normal grid generation happened. Initially we were having manual monitoring, central generation was there, power was generated at central level. Then after that, what we have done, smart grid 1.0, 1990s, advanced metering reading, grid management has come. Then smart grid 2.0, if you see, advanced metering, communications are there. Smart grid level, if I see, 2020s, now we are integrating renewable energies. Initially, at one place, power was generated. Slowly, meters we have considered. Slowly, two-way communication. Now, not at one level. At home, if you consider home, rooftop PV is there. Throughout the lines, if you go, we are having wind machines are there. Throughout highways, if you see, PV mills are there. Future, no, PV integrated EV charging stations will be there. So now, initially, from one system it is considered, then the communication networks is increased, grid is increased, then the advanced metering is increased, communication networks are improved. Now, integration of distributed grids is enhanced. Future grid, no, fully decentralization. We are going to install smart meters throughout the network. And even though main connectivity supply is not there, grid is not there at home, nowadays you are having inverter, you are having rooftop PV is there. You can work with roof. Now, no house is without light evening. Previously, when power supply was not there, without light you are there. Now, every house is with inverter. Now, most of the houses now with PV is there, rooftop PV. Now, it is decentralized now. What I mean to say, the systems are decentralized. Okay, in the future, you are having decentralized networks will be there. Optimization will be very, very high. That's I want to show from here. Okay, so here what is happened? I will connect with industry smart energy. So from initial smart power to initial steam power to now mass production of electricity happened. Then I have included automation and computers. Then we are considering intelligent networks. Then we are going to smart grid networks. How smart grid networks? Human machine collaboration. Okay, so when you see the overview of integration of smart grid with 5.0, so we are using vehicle to grid connections, we are considering advanced metering structure, we are considering AI driven maintenance, we are considering blockchain technology, cyber physical systems, EVs, wind, even real-time data analytics, smart management system, manufacturing, we are considering data analytics. Okay, so what I mean to say is, when it comes to applications in the smart grid, real-time any fraud detections, dynamic load balancing, infrastructure optimization, regularity, customer engagement. What does it mean? Suppose you are considering PV integrated grids or wind integrated, battery integrated grid. If you consider any cybersecurity happened, or cybersecurity and smart meters, you are considering any data is theft is happened, cybersecurity issues, anything is happened. Okay, load. Suppose how the load is balanced or not. Now from the grid, how much you are taking. Now PV you are having. How much from PV you are taking? How much from battery you are taking? So how much you are utilizing. This is also important. Infrastructure wise, suppose you are having so much of infrastructure. That one are you optimizing or not? Or are you every time are you taking only from the grid? Or if you have excess power is there, are you giving back to the grid or not? So my meaning is what I mean to say. So the applications also not only security wise, load balancing wise we need to see. Optimizing the network is required, and regularities are important, and consumer engagement also required. Okay, so we need to see intuition, empathy is important, enhanced decision making, and precision in automation also required. So when you consider earlier generation was only through this, and it is generated and transmitted throughout network. Now we are having PVs, winds, okay, phase measurements units are there, which is transmitted, distributed. Now people are tracking the data with the IoT, Internet of Things, SCADA, supervisory control and data acquisition. They're tracking the data of generation, tracking the data of transmission and the distribution data. And distribution center, again, computers are there. They're tracking the data of here from the distribution centers and consumption load point of view also. And people are using here also sensors. So what I mean to say, even electricity sector also, not only computer, even electrical sectors also, we are integrating the in transmission phase measurement units and computer networks we are using. We are making AI intelligent base. We are tracking the data with the help of sensors. In distribution also, we are tracking the data from the sensors, and we are using the communication protocols for residential, industrial, and commercial levels also. So since we are installing the sensors throughout the network, generation, transmission, distribution, and home level, so the data can be tracked with the help of wireless sensor network. It will be sent to the routers, and the cloud data is stored. And at any time, you can track the data. Okay. Now, suppose now any attack is happened in the distribution grid or in the transmission grid, attack is happened. Okay, attack on the generation, any attack is happened, or on the transmission is attack is happened, or on the distribution attack is happened. What will happen? The data will be there in the SCADA systems. So energy management system, demand side management people, they will understand, yes, data theft is happened, or energy theft is happened. The people can notify through the communication and power link. So communication link is, we will get the data is theft is happened through the communication protocol we will get. If power theft is happened through the voltage tracking, current tracking, power tracking, we can enhance. So what I mean to say is, it's not just in one industry. My intention is only one thing. It is not in only CSC or other departments. In each and every field, IoT play a vital role. Okay. So now from generation to till distribution, what we are doing, we are collecting the data, monitoring and controlling the data, analyzing the data, and connecting it. Okay. So this is what we have done is, in 1784, steam power 2, it is started. Then 1870, industry 2.0, we moved to mass production assembly. Then compute 1970s, we consider industry 3.0. Then 2010 and now cyber physical system, IoT networks, industry 4.0, wireless sensor networks we consider. The future industry 5.0, what we are going to consider systems and work together. So 1 to 5, this is the stages now. Okay. So any queries? Sorry, another session was there, I think. So what we have done, so just give me a minute and let me comprise it. So what we have done, we have discussed about what is industry 4.0, fourth industrial revolution, which includes IoT, AI, robotics, and other things. Now, IoT in industry automation is IIoT. Here, sensors, actuators, communication protocols we are considering, through which flexible efficient systems we are getting. So we have 1.0, 2.0, 3.0, 4.0. Now, so IoT has started in industry 4.0 only. So how it is improved, we have seen first. Then we are using sensor networks in industry 4.0. Then after the strategic plan, how was past, how is present, how is the future, we have seen. Now, applications we have seen in the industry 4.0, smart factories, cyber physical system, internet of things, big data analytics, cloud computing, and these things we have seen. Then after that, consumer level IoT, industrial level IoT I have seen. Then after that, what we have seen, IoT applications we have seen. Then after that, industry level applications we have seen. Then practical applications we have seen. Then after that, what we have seen, then differences between Internet of Things and industry Internet of Things we have seen. Category wise focus, how the focus, consumers only, here their complex systems, data wise, objective wise, security wise, okay, infrastructure wise, examples, everything we have seen. Then benefits we have seen. Then after that, Internet of Things versus industrial commercial IoT versus industrial IoT we have seen. Then some examples we have seen. Okay, so case base of automotive industry, aerospace, healthcare, heavy consumer level we have seen. Segment wise also we have seen. Okay, so once the segment wise is done, then challenges, benefits we have seen. Then, so I have taken to a more into smart grid level. Okay. So now, sorry. Next, another one is there. No, any queries? Is it okay? At least do you understand?
Yes, sir. Yes, sir.
Yes.
Yeah, we understood, sir. Yes.
I made it more slides. Sorry, I thought like from 1.0 to 4.0, how it went. No, I thought of giving data. And the main causes
Yes.
difference between consumer IoT and industrial IoT difference you should understand. That is my intention.
Yes.
Sir, I'm having one question.
Uh,
Hello, excuse me, sir.
uh,
I'm having one question.
yes, ma'am.
Sir, what are the major challenges in implementing IIoT?
That's what I have shown you, ma'am. Here, can you see? When you are implementing, no, the risk is very high. What cybersecurity issues, whatever you are using the this one, no challenges. Can you see here? One is initial cost is very high. Okay, cybersecurity,
Data
data
theft is
privacy,
data theft.
privacy.
Yes.
And when you are
Uh-huh.
integrating, no, integrating machines with cybersecurity and IoT, then you have to tag properly. Initially, it will take so much time, but once you have done, it will become easy.
Okay. Okay.
And handling
Yes. Yes.
large data, you should have a skilled person is required. See, earlier,
Yes.
earlier in industries, even non-skilled persons are used to work. But now, when you use industry IoTs, now every every
Okay, sir.
any other thing.
Okay, sir. Thank you. Thank you.
At least overview, you people understand. At least overview.
Sir,
Yes, sir. Yes, sir.
one of our participant is asking, sir, hello, hello.
Yes, yes.
So
You asked the question,
one
ma'am.
of the participant is asking,
Uh,
what future
yes, ma'am.
trends are expected in IoT for Industry 4.0?
That's what no industry 4.0 future trends is the mainly based on already people started using. If you see here, can you see this case studies I have shown you? What is that? In the smart factories, they are using self-learning plants. So I have shown you even in the BMW, some examples I have taken here. See, Siemens, no IoT sensors, robotics, they are using AI. Now, no one is going to consider only one particular thing. 2 or 3 sensors, IoT, digital twin consider, so that they will get the better outputs. It's not like just IoT, it's not just AI, it's not just digital twin. All mainly you can say cyber physical systems people are going to consider. That means machines with digital systems they are going to consider. I can say CPS, cyber physical
Yes.
systems people are going to consider. Machines with
Yes.
a digital systems they are going to consider, so that efficient networks they can create. Future is going to be cyber physical systems. I can say in one word.
Yes, yes, sir. Okay.
Shreya,
Yes, ma'am.
sir, I request you to please give vote of thanks. Sir, because of sir, we are
Yes,
sorry
ma'am.
because of time constraint. Uh, we'll conclude your session, sir. Okay. Yes.
Yes, yes, I understand. Generally, my lectures are a little bit lengthy. Sorry for that.
No, sir.
Sorry.
No, sir.
Very
We got a clear
informative
idea.
lecture, sir.
And Shreya, yes, very
Thank
informative.
you.
Shreya,
Yes,
can
ma'am.
you please
Yes, ma'am.
express vote of thanks? Okay.
Yes, ma'am. On the behalf of the Shri Bayasaheb Mane Shikshan Prasarak Mandal, a Shukramani group of institutions, I extend my heartfelt gratitude to Dr. Suresh Mikili sir for his insightful and inspiring session today. Your expertise in smart grids, electrical vehicles, power quality, and photovoltaic systems has not only enlightened us but also motivated our faculty to explore new research directions. We are truly value your time you have been taken out to schedule the share your knowledge and experience with us. Your contributions as an educator, research, author, and mentor are remarkable. Today's session has been testimony to your dedication to the advancement of electrical engineering. I also thank all the participants. With this, we express our sincerely appreciation to you, sir. We look forward to more enriching interactions in futures too. Thank you, sir. Now I
Thank you,
would
Dr.
like
Nikhil, sir.
Thank you.
Thank you,
Thank
sir.
you, ma'am. Thank you all.
Thank you, sir. Thank you very much.
Okay.
Thank you.
now
Thank
I
you,
would
sir.
like to open
Sorry
the
for
floor for
inconveniencing initially. Thank you.
No,
No,
sir.
no, sir.
No issue, sir.
Yes.
now I would
No.
like to open the floor for the participants. If you have any doubts, you can ask in the chat box or you can ask by on the
You're
mic.
asking queries. Sorry, you're asking queries, sir.
Ma'am, ma'am
Yes,
will
we will collect the questions, sir, and we will
No issue.
communicate you, sir.
Thank you. Another session is
Yes,
starting, no?
yes,
I hope.
yes,
Madam,
yes.
Is it okay?
another resource person has already joined.
Sorry,
So
sorry,
Join.
sorry.
continue
Bye,
with
bye.
this.
Bye. Thank you. Good night.
Okay.
Yes. Okay, sir. Thank
Good
you,
night,
sir.
sir. Thank you.
Now
Shreya,
I'm-
please continue.
Yes, ma'am. Now we are moving towards our next session. We are lucky to have Mr. Rohit Kadam sir with us today on session 10 about the artificial intelligence and machine learning in manufacturing, quality control and process improvement. On the behalf of Sri Bayasaheb Mane Shikshan Prasarak Mandals, Ashok Mane Group of Institutions, I heartily welcome you, sir.
Thank you.
Mr. Rohit Vijay Kadam sir is a dynamic entrepreneur and technologist currently serving as a managing director of a RoboSap Innovation Private Limited, a fast-growing startup in Nipani, Belgavi, Karnataka, focusing on artificial intelligence, robotics, and automation. He is also founder of a software solutions and Infinity Agrosystems, and a co-founder of a Quix Innovations, all of which are driving innovations in AI, IoT, agriculture, healthcare, and industrial automation. Academically, he holds a BE in Mechanical Engineering from VTU Belgaum and MTech in Artificial Intelligence and Machine Learning from the prestigious BITS Pilani, Rajasthan. His educational background combined with the entrepreneurial spirit, he enabled him to bridge the gap between the cutting edge research and the real world applications. Since he is an incorporation in 2017, RoboSap Innovations has delivered impactful solutions across the domains like robotics, 3D printing, automation, and AI-driven product development. Some of the flagship innovations include Photon, an autonomous UVC distinguished robot, Thermogate, a smart temperature scanning systems, Agrobot, an AI-based agriculture robot, and several IoT-driven automation systems. These innovations have gained a wide recognition for solving real-world industrial, agricultural, and societal challenges as well. Under his leadership, RoboSap has also launched 6 software solutions specializing in web, mobile, and game development, as well as Robosop.in, an e-commerce platform providing robotics and electronic components through Unix innovation. He is contributing to Industry 4.0 solutions with a focus on AI, IoT, healthcare, and civil automation. Beyond the entrepreneurship, Mr. Kadam is a passionate mentor and innovative too, delivering technical talks, workshops, and training programs on robotics and embedded systems to schools, colleges, and engineering graduates, inspiring the next generation of the engineers. With his vision of building smart gadgets for the smart people, Mr. Rohit Kadam contributes to pioneer in the fields of the artificial intelligence, IoT, robotics, and automation, working towards creating a smarter and more efficient future. We welcome you, sir. Over to you. Can start your session.
Welcome, sir.
Welcome you, sir. Welcome, sir.
Yeah.
Yeah, over to you,
Okay.
sir.
So I'll just share the screen first.
Yes, yes.
Good evening, everyone.
Good evening,
Good
sir.
evening, sir.
Yeah. So this session will be dealing with artificial intelligence and machine learning in manufacturing, quality control, and process improvement. So this session, what we'll be dealing with is how AI and ML they are transforming modern machinery manufacturing operations with special stress on the quality control as well as process improvement related applications. So before I actually start with the session, so we'll first discuss the agenda of this session. So throughout this session, I am planning to throw some light on these particular topics. So since the time is limited, so I'll be throwing some light on these particular topics with real world use case or industry related examples. So in the first case, we'll start with introduction to industry 4.0. So I think that it is not the first day of this session. So you might have already learned or heard about this thing through the previous sessions. Second one, after that, we'll be discovering some of the basics of AI and ML in manufacturing. So there is a general confusion related to AI, that is artificial intelligence as well as machine learning. So the way in which you can implement machine learning to the manufacturing related operations and the way in which you can implement artificial intelligence to manufacturing related operations, there is a huge difference between that. So it depends from the industrial operation as well as from the industry to industry. So we'll be dealing with the differences on how we can implement machine learning to specific industries and how we can implement artificial intelligence, which is backed by machine learning. After that, we'll be discussing somewhat regarding predictive maintenance. So what actually predictive maintenance is and how it is different from the traditional maintenance related strategies. After that, we'll be also discussing somewhat related to quality control and inspection. So since this session is related to artificial intelligence in manufacturing, so we'll be also throwing the light on how quality inspection, quality control happens, and how artificial intelligence, machine learning, as well as deep learning related techniques, more specifically computer vision related techniques, can be used on industry floor as well as can be used for inspection of industrial components or inspection of assemblies in industry related operations. Next one, important one is process optimization. So how the process of manufacturing or process of taking the product from the idea to the market can be optimized using AI related tasks. After that, the most important one is supply chain and logistics. So how artificial intelligence can help improve the current supply chain and logistic related scenario. Next, we'll be discussing somewhat related to digital twins. So what are digital twins and how AI can improvise the current digital twin related trend. Next one, human robot related collaboration, or how cobots can be used instead of traditional robots, and how AI is going to assist in applications which are going to use cobot. And after that, we'll be also discussing somewhat related to lean manufacturing, that is reducing the waste. So any industrial related application, whenever you procure some raw material, whenever you are going to convert it into finished products, so there's like as much of importance is given to the reduction of the waste. So sourcing also matters. Other than that, reduction of the waste also matters. So how AI can help in reduction of the waste. And at last, we'll be discussing something about Industry 5.2. So without wasting much time, we'll start with the session. So first, let us see the evolution of manufacturing. So maybe you have learned regarding these things somewhat. You have learned regarding these things in the previous sessions also. So I won't be taking much time on this particular topic, that is evolution of manufacturing. So evolution of manufacturing started with the first industrial revolution with the mechanization. So when Industry 1.0 was released, so everything was related to the mechanization. So mechanisms, machines, implementing or designing of machines for performing the tasks which usually humans used to do. After that, second industrial revolution, it came with electricity, mass production and assembly lines. So from batch production systems generally transitions to mass production and this assembly lines. In third industrial revolution, somewhat level of automation was introduced. So computers came into picture with Industry 3.2. So PLCs came into picture. So at present also PLCs are used for almost 70 to 80% of the industrial automation scenarios in small and medium scale industries. Next, at present day, Industry 4.2 is trending, or Industry 4.2 is in picture. So at present, it is also transitioning into Industry 5.0. So Industry 4.0 is characterized by interconnectivity and intelligent systems. So Industry 4.0 usually deals with intelligent systems, which consist of different sensors, data analysis, data science, artificial intelligence, machine learning to work on that data, perform the analysis, and then improvise the production or manufacturing related operations. So what Industry 4.2 consists of? So it is nothing but it is the smart factory era. So like previous industrial revolutions, which mostly focused on mechanizations or development of the machines mechanisms for making the task easy, Industry 4.0 is characterized by interconnectivity. Or more specifically, Industry 4.0 came into picture because of IoT and IIoT, that is nothing but industrial IoT, utilizing number of sensors to collect the data from the different machines, different factories. So all such things came into picture with the Industry 4.0. So Industry 4.0, it usually consists of four basic things. One is artificial intelligence. So artificial intelligence, it consists of systems which are capable of sensing, analyzing, learning, and adapting in real time from the data. Next, Internet of Things. So Internet of Things, it usually consists of connected sensors and devices which are generating massive data streams. After that, cloud computing, whatever data has been collected from the IoT related systems. So IoT related systems, they usually form the perception layer or the sensing layer in Industry 4.0 related system. So they are the first line of this thing, which are responsible for collection of the data from the smart machines or smart industries. So once the data is collected, they will be transmitted to the cloud related application. So that cloud related application is capable of processing and scaling this complex data to analyze the patterns within that data using artificial intelligence and machine learning related techniques. So after that, next one is advanced robotics. So advanced robotics, based on the data analysis, finally improvising the things or performing some tasks on the basis of the data which has been collected, transmitted to the cloud, analyzed by the AI system, and then finally performing the task which is expected to be performed. So basically, in this session, we won't be focusing much on IoT or IIoT related tasks. So we'll be focusing on AI and ML, or application of artificial intelligence, machine learning, and deep learning to the core of Industry 4.0. So why AI and ML systems are important? So these systems nowadays, they are not optional. So before some years ago, the scenario was there was not much of the data available. So basically, the basic requirement for any artificial intelligence or machine learning related system is availability of the data. So if you see the scenario of 2008, 2010, so that time huge and enormous amount of data was not available. So the systems were just transitioning to Industry 4.0, implementing of the smart sensors, collection of the data to determine the anomaly in that particular operation. So those systems, at that time the data was not available, but at present, as of 2025, in every particular industry or in every particular industrial scenario, manufacturing scenario, or even in domestic scenarios, you take any field, there is enormous amount of data which is available. So this data availability has triggered some advanced concepts. So these artificial intelligence and machine learning techniques can be applied on this data to analyze the hidden patterns or to improvise the way the products are being manufactured, the maintenance has the way in which the maintenance is being made at the present using traditional approaches, or even supply chain related things, or some kind of digital twin related system which runs parallel to the actual physical model. So I'll get to the digital twins in the upcoming slides, but just to stress that nowadays artificial intelligence and machine learning, it is not at all optional. So if we are from technical background or any industry, if they want to improvise or if they want to multiply their profits with minimum amount of investment, then they are expected to implement this artificial intelligence, machine learning, and IoT related systems in their industries or in their machines. So how AI and ML works in the core of Industry 4.0. So basically, machine learning algorithms, they are going to monitor the thousands of sensor signals. So it can be related to a single machine or it can be related to the multiple machines. So suppose there is a company A which is selling thousands of products. So just for example, we'll take a use case of roti maker. So roti maker, it was developed by US based company, usually from Indian origin, but they are based out in US. So what they did is, in each and every roti maker, what they have done is they have implemented this error code related system, and whatever sensors are there in that particular roti maker, they are going to continuously feed the data which is available from each and every individual roti maker they have sold over the years into the cloud-based platform. So using this data, the ML algorithms which run on the cloud-based platform, what they are going to do, they are going to analyze the sensor signals from such thousands of devices in real time, and they are going to detect the anomalies in the operations. So which is usually like difficult for human operators. So if there is a consumer who is operating that machine, it is difficult for such consumer to detect such kind of anomalies, which can result in errors in future. So error might come in future or error has already come. So this data will be already fed to the backend system. So this particular ML related algorithm, it is going to give an automated solution to what kind of error it might be, whether it requires servicing or it can be rectified by the customer itself. So this is how the AI and ML related system works at the core of Industry 4.0. So if you're implementing, so this is just a general use case. So there are many examples which we'll be discussing, or many useful examples, right from large scale industries to small and medium scale industries, how they can improvise their production system, manufacturing facility, as well as supply chain using the techniques such as artificial intelligence and machine learning. Next, we can also consider AI-powered vision systems. So they can be used for inspection or vision-related inspection of microscopic defects, so which are usually impossible for human eye to detect. So next, another example can be predictive models which can forecast when the machine is likely to fail. So instead of performing maintenance whenever the machine fails, you can perform it prior to the machine whenever the machine is likely to fail to avoid the downtime. So again, why AI and ML are no longer optional, we'll discuss this thing. So if at present, if we are from technical background, doesn't matter from which particular field we belong. So whether we may be from mechanical background, whether we may be from electronics background, computer science background, or specialized in AI related background. So it is mandatory to know the concepts related to artificial intelligence and machine learning. So there are thousands of problems which are existing at present, which are yet to be, or AI and ML related algorithms and techniques are yet to be applied on these problems to improvise the solution, or to come up with a completely innovative solution which is far more effective compared to the traditional approaches. So let it be to manufacturing sector or let it be to any other sector. So here we are going to discuss why AI and ML are no longer optional. First thing is customer expectations. So today's customers, so usually the mindset of customers is also changed. So if you have a manufacturing facility, you will have to think from the customer first approach. So today's customers, what they want is, they usually demand products as per their personalized requests. So second thing, faster delivery, and they need higher quality as well. So here AI and ML systems can come into picture to analyze the customer trends or analyze what customer actually wants, and then improvise the product as per the customer's demand. Next, global competition. So this is not new. Global competition already exists on almost every product. Next, stricter quality standards. So this is important. So at present, we used to be under the influence that whatever products which are coming from China related market are of low quality or cheap quality. But at present, they also improvise their quality standards using these AI and ML related inspection systems and quality inspection systems to such an extent that human quality and visual inspection is going to fail in front of that. Next one is sustainability demands. So industries, they usually face the pressure to reduce the environmental footprint. That is what pollution is usually happening from that industry for that particular manufacturing facility. Other than that, they have the stress of optimizing the resource usage to maximize their yield or maximize their profit. Also to adapt to the circular economy principles. So D&D new rules from the government are being rolled out. So they will have to keep up with those rules as well. So because of this thing, so they can implement AI and ML related systems to the entire manufacturing plant, right from the raw material to supplying the product to the end customers. So companies usually they must produce at higher quality with less cost and waste, which is nothing but a part of lean manufacturing. So because of this, AI and ML at present are no longer future technologies, or you cannot say that AI and machine learning, artificial intelligence, machine learning, or artificial intelligence, machine learning, and deep learning is the next big thing. So it is not the next big thing. It is used. It is currently over here. So it is up to us, or it is up to the industries how to implement artificial intelligence and machine learning to maximize the yield, to improve their operations, to improve the quality, to improve the transit time, which is big, or to reduce the manufacturing time for the particular product. So as per the report, so if you see the scale of opportunity, so the application of artificial intelligence and machine learning, as per vacancy report, it estimates that it can contribute up to 3.7 trillion annual value by 2035. So these particular values, so contribution to the economy by implementing the artificial intelligence and machine learning systems in manufacturing, quality control, and process improvisation, usually it is going to come from what? Predictive maintenance. So if you implement something called as predictive maintenance, so if you are able to predict the maintenance far before it occurs, what happens is losses will be minimum, downtime will be reduced because of this ultimately you will be able to produce more in that particular amount of time with minimal losses. Next, real-time quality control, eliminating defects. So usually quality inspection, how it happens, or in majority of the cases, what happens is, so quality inspection, if you declare the product as failed, so whatever process has been required in implementing or whatever process has been required in manufacturing that particular product, so that much amount of time and resources will be wasted in that particular thing. So real-time quality control is important. So see what I'm stressing. I'm stressing on the term real-time quality control. So throughout the stages of the production or throughout the stages of the manufacturing, your quality control is important. So if you come to know in advance that this particular product which you are manufacturing, so there is stage 1, stage 2, stage 3. Just for example, consider your product which is going to pass through this all production or all manufacturing stages. So from stage 1, stage 2, stage 3. So at particular, if you press on real time, so if you get to know that this product at stage 2 itself, you get to know that this product is going to fail at stage 4. So that time you can usually avoid the losses and time and resources which the industry will be investing in that particular or manufacturing of that particular product. Next, digital twins. This is the most important concept. Again, digital twins, it is widely implemented by the large scale industries. So digital twins, they are accelerating design and lifecycle management. So I'll come to the part like what digital twin is and how actually the digital twin works. But digital twin is the virtual replica of the actual product. So it is going to fetch the data from the actual product, but simultaneously it is also going to simulate the working conditions of the actual product, and then it is going to predict some kind of improvements or any other predictive maintenance related things can also be done using digital twins. Next, process optimization for improving efficiency and reducing the energy use. So important thing, energy usage has to be reduced. Next, improving the efficiency of the production. So all three factors which I have suggested above, or all the three factors which I have quoted above, they are ultimately they are going to improve the efficiency as well as they are going to reduce the energy use. And last one, the most important one. So usually majority of the losses industries face, they are in supply chains as well as in the inventory cost. So usually what happens is if you are not aware of the demand, so you usually end up stocking the excess inventory. So that much amount of funds are invested in the excess inventory. So these funds can be utilized somewhere else. Other than that, if you're not aware of the demand in production time, the whatever production time it is going to take to complete that order, again, that will be a problem. Other than that, supplying that particular product to the end customer or end business, again, so supply chain also matters equally important as like quality control and inspection or your production related predictive maintenance and other things. So artificial intelligence and machine learning, it can be implemented at each and every step of manufacturing, right from sourcing of raw material to finally finished product, so that your cost will be reduced, your resources will be reduced, again energy consumption will be reduced, quality can be improved, and your production time can be reduced, as well as proper supply chain can be managed for that particular product. So these are just general examples of real world AI success stories. So it is not new artificial intelligence, or rather than telling we are dealing with industry 4.0. So let me stress that we are actually into industry 5.0 now. So majority of the industries, they are slowly transitioning into artificial intelligence, machine learning for most of the operations. So whether it may be production related operations, manufacturing related operations, or any other backend related, design tasks are being performed by AI related tools now. So or suggesting the improvisations in the design. So there are many fields in which artificial intelligence, machine learning, deep learning, other than that generative AI, all those things can be applied. The most important one, explainable AI is also into picture. So explainable AI, rather than telling whether there is a defect or whether there is no defect, mostly stressing. So development of such kind of artificial intelligence model, agents or ML related algorithms, which can also tell due to what reasons the defect might come, or it can explain the prediction. So why it is, or why it has arrived at that particular prediction, or why it has resulted in such kind of predictions. So such kind of AI related systems can be applied in improvisation, in the quality control, manufacturing, as well as the process improvisation. So if you take the examples of real world AI success stories, so I'll just quote a few popular ones. There are many industries which are usually implementing AI. So General Motors, they are already using predictive maintenance to avoid costly assembly line stoppages. So due to, if there is some downtime in the assembly line, then it is going to cost huge losses. So predictive maintenance can cut down those losses by telling or by predicting the maintenance which is going to arise in future. Next, BMW for quality inspection or quality control of parts, it already implements AI vision systems. Even recently, Adani systems have implemented AI vision related systems for quality inspection of their parts, so usually which is restricted to Adani Power, that is solar power, solar panels which are being manufactured, defect inspection in those solar panels. All those things are being done using AI vision related systems. Next, GE Aviation. So GE Aviation at present they do employ digital twins to predict jet engine performance and optimize maintenance schedule. So instead of having fixed maintenance schedule, so it is better to have proper or optimized maintenance schedule. So maintenance can be done only when it is required, rather than doing the maintenance at fixed specific intervals. So this time, in this way, you can also reduce the losses and you can also improve the efficiency. So before we go into AI and ML in manufacturing, so let us understand the foundation of intelligent factories. So unlike consumer applications, what we do is AI and ML in manufacturing is usually deployed in high structured environment where the primary focus is precision. So it should be able to do it with precision, not just doing it, but each and every time doing it with precision. Reliability, because the system which you are deploying should be reliable and it should have maximum efficiency. So what kind of AI related tasks can be performed in manufacturing related operations? So this is just the first introduction. So we'll slowly transition from manufacturing. We'll discuss some parts regarding manufacturing, how AI and machine learning algorithms or AI algorithms and machine learning systems, they can be used to improvise the manufacturing related operations. After that, we'll move towards the quality control. So as much as manufacturing quality control is also important, how artificial intelligence and machine learning can help in better quality control. After that, we are going to move towards process improvisation. And after that, we are going to move towards the lean manufacturing, stage by stage. So right from manufacturing to improving the efficiency of manufacturing, I'm just going to throw some light on what kind of techniques and what kind of algorithms or AI related systems can be used. So first one, in manufacturing, you can use computer vision. So AI related computer vision, they can be used for detection of defects. So this is a part of quality control. Next, they can be used for classification of the items. So suppose we have a conveyor which is supposed to segregate different items. So vision systems can properly do it. Other than that, alignment of the items. So whenever the items move over the conveyor, if you want the items to be aligned in a specific orientation only when they reach the particular endpoint, so that can be done using AI vision related systems and robotics. So some kind of vision related AI related model, it can determine the alignment and then it can trigger the robot to properly align that particular item or align the items which are misaligned. Other than that, guide robotic arms with precision or high precision related tasks. Next, second application of artificial intelligence in manufacturing is predictive analytics. So predictive analytics, what it deals with is, it usually analyzes the sensor data that is in two forms. One is the real-time sensor data and another one is the historical sensor data. So whatever has been collected till now and what is the present sensor data. So it can be used to forecast the failures. It can be also used for demand fluctuations. So if you know well in advance when the demand for this particular product is going to increase, then likewise you can adjust your production schedule. After that, it can also give you the production outcomes. So with particular settings or with particular configuration, what might be your yield of that particular production? So how much products might get rejected in quality, what might be the yield? So all these things can be done in the predictive analysis. Next one is natural language processing. So natural language processing, it usually enables voice activated commands, maintenance log analysis, and smart chatbots for troubleshooting. So imagine you develop a particular machine which can interact with a voice or some kind of chatbot which is implemented in that particular system itself. So if you have complex mechanical structure, so you can even train large language models like custom GPTs or custom this thing. So which can analyze the data and which can give you the suggestion based on the performance of that particular machine. So how you can improvise, or if any predictive maintenance related signals are being generated and all such things. And reinforcement learning, specifically even reinforcement learning is important. So reinforcement learning is what? Reinforcement learning, the system learns to adapt to optimal actions through trial and error and based on the rewards. So this is the basis of agentic AI. So usually through trial and error, the system can learn to optimize the actions. So the example for reinforcement learning I'll give in our upcoming sessions for easier understanding. So now coming to the machine learning approaches. So one thing you need to understand, machine learning is totally different from artificial intelligence, and it is also totally different from deep learning. So here ML related approaches, so even these are the subsets of each other. So there is a difference in the approach. Whenever you say machine learning, or whether if you have a particular use case, suppose we have some kind of industry which needs to be in which we need to implement AI and ML related systems. So by analyzing their process, analyzing their production schedule, what kind of items they are producing, what kind of production line they have, so what kind of manufacturing processes they are implementing, you can decide whether to use a machine learning related this thing, or whether to use an agentic AI related approach. So in machine learning, what we have is there are three basic types of machine learning. So there are many types, but we'll stick to these three types. One is supervised machine learning. You usually learn from the data, and on the basis of that data, what you do is you try to predict on the unseen data. So this is nothing but supervised machine learning. So as an analogy, you can consider supervised machine learning like an exam, semester end exam, which we are giving. So you learn throughout the semester, and on the basis of whatever you have learned in the semester, you try to answer the questions which are totally unseen. So if the question paper is unseen, if you have not come across those questions, but you have come across the similar kind of questions or similar kind of problems whenever you are proceeding throughout the semester. So this is the general case of supervised learning. Learn from the data, predict on the unseen data. So such kind of systems, they can be used to train thousands of product images to be labeled as defective and not defective. And after that, you can perform quality control inspection to determine whether that particular product which is manufactured, which is defective or not defective based on the things which it has learned previously using the imaged or labeled image data. Second one, unsupervised learning. In unsupervised learning, what happens is, in unsupervised learning, we are not teaching it anything. It is going to learn from the patterns. Okay. So for example, I'll just give an example analogy for this particular thing as well. So if you need to classify the objects on the basis of shape, okay. So there is a pattern for each and everything. So if you have triangular object, you have circular object, or you have square related object, what happens is, so all the triangular related objects are going to form a cluster, all the circular related objects are going to. So here in unsupervised learning, we are not specifically labeling it as triangular, circular, or square. So the system is going to, on the basis of whatever it has learned from the patterns, it is going to cluster or group it into a particular distance. So classic example can be grouping the sensor readings from machines to identify the unusual behavior. So whatever real-time sensor data you are collecting, so if there is something, or in technical terms we call it as an outlier over here. So if there is something which is not, which doesn't match with the proper flow, then it can be flagged in that particular case. And in reinforcement learning, I have already explained in the previous slide. In reinforcement learning, what we do is we are going to develop such systems which are going to learn on the basis of trial and error, on the basis of reward or feedback. And there will be a reward if you are implementing, or if your results are going to match properly. There will be a penalty if your results are not going to match properly. So classic example of this we can consider optimizing the robot arm movements to minimize the energy while maximizing the speed. So you can go through the set of operations in which you can minimize the energy consumption, keeping the speed of operation of that particular robot at maximum. Another classic example, you can take 3D printer. You can configure an AI model to configure the settings on the fly in such a way that whenever you are printing, depending upon the model which you are given for that particular 3D printer to print, it is going to determine the optimal printing conditions on the basis of this reinforcement learning. So what kind of printing speed to set, what kind of layer height to set, and all such things. So these are the machine learning approaches which can be used for, or which can be used in manufacturing. So next one, whenever you talk about the term artificial intelligence and machine learning, the most important thing you'll have to consider is data. Another thing you'll have to remember, garbage input is equal to garbage output. So if you don't have sufficient data to train a AI or ML related system, then your system is not going to respond properly. So you are going to get worst results. You are not going to get any accuracies out of that thing. And whenever you are implementing it in real world use case scenarios, so we have seen examples wherein whenever you are collecting the data, splitting it into train test validation set, performing the validation, you might get exceptionally good results whenever you are doing bench testing or whenever you are testing the algorithms in the software. The moment you implement it on the real world data, the system is going to fail drastically. So what is important in AI and ML related system? The first source is the data. So if you have proper data, you are going to get proper results, or else you are not going to get the proper results. So how you can source the data, or what are the different sources of data in manufacturing? So whenever we talk about implementing artificial intelligence and machine learning in manufacturing processes, so data can be obtained through different sources. So first one is your IoT sensors, as explained. So if any previous session we have dealt with IoT, even this can be considered. So IoT sensors are IoT sensors whenever you are using it in industrial use case scenarios. So they are going to monitor, just for example, they are going to monitor the parameters which are related to that particular machine, or which are related to that particular system. So they are used to measure the temperature, vibration, pressure, humidity, energy consumption, or providing real-time health and performance analytics. Similarly, you can also have the visual data. So it is usually used in quality controls, process inspection, or classification. So visual, or even it can be used for operating of the cobots and robots. So cobots I will be again discussing in the upcoming slides. Next, production line data. So production line data, it is important for process improvisation or process optimization. So cycle times, throughput, downtime, how much amount of scrap is generated. If you have a machine shop, then how much amount of scrap is generated. What kind of yield percentages that can be used to optimize production. So whenever you are taking for a period of time, so suppose you are collecting the data for 2 or 3 months, on the basis of that, you can collect the data from the production line, and you can use AI and ML related systems to optimize the production line or production line related tasks. And last one, supply chain, very important again. So it can be used to demand the forecast. So what kind, forecast the demands. So what kind of demands are going to be there in future? After that, how much lead times can be there? Other than that, inventory levels, whether you need to stock the inventory or whether you don't need to stock the inventory. When can you avoid excess stocking of inventory based on the forecast of that particular demand, and logistic performance for end-to-end optimization. So whenever you talk about any ML related systems, so usually you take any ML related application. So if you're developing for any ML related applications, it consists of 4 to 7 steps. I've just shortened it to 4. So first one, most important one, I already told in the previous slide. Whenever you are talking about AI and ML, the first important thing is data. So first thing is data collection. So usually you can take an example. Suppose you have a use case where you need to develop a ML related system for detection of the anomalies in that particular. So consider an example of hydraulic press. So you want to collect the data from different sensors, and then you can or then you need to analyze the predictive this thing, when can maintenance happen, or you can also predict the remaining useful life of the components, whatever pumps are there, or you can also calculate the wear and tear of this thing on the basis of oil viscosity levels. So what you need to do is, first important step is the data collection. So here sensors, they are going to gather millions of data points from machines, processes, and environment. So I just given the example of hydraulic press. Here you can implement it to any industry or even a specific machine or component used for production. Next, processing. Again, ML or AI algorithms, they can be used to clean, normalize, and analyze the data to identify the patterns and anomalies. So whether it may be a supervised learning, whether it may be unsupervised learning. So usually second step is the processing. Next one, insights. So what insights means? So there is something called as feature engineering or feature selection. So after featuring, when you collect the data, you have done the processing, you need to identify the features in that particular data which are responsible for prediction of the output. And on the basis of that, you are going to train the ML or AI related system to provide the system insights. So whatever your interest or whatever your area of interest is, so on the basis of that, system is going to generate the predictions. So if you have trained the model for your predictive maintenance, it is going to generate the predictions related to the maintenance schedules. So when you are supposed to perform the maintenance on that particular machine, or whenever there is a part of some kind of part in that particular machine is going to fail, so all these insights are going to be given. So if you want to determine any other thing, then you can generate the insights for that particular thing. So for classification, insight will be usually detecting the parts into and separating it into, or generating the control command for separating those parts into different categories. Next, final step is your action. So in action, what happens? Operators are automated systems. So what operators are automated systems? They are usually going to take actions based on the insights, creating continuous improvement of loop. Now, we have just discussed the basics of AI and ML in manufacturing and process improvisation related operations. Now we will be moving towards predictive maintenance. So anyone, if you have any doubts, you can either ask me at the end or you can interrupt me anytime if you have any doubts. That is not an issue. So here, now next we'll look towards the predictive maintenance, second important application of artificial intelligence and machine learning in manufacturing process control and optimization. So what predictive maintenance is? So whenever, or in general terms, predictive maintenance is predicting the failures or preventing the failures before the actual failures they happen. So here the term predicting, preventing, what it stresses is it should be early detection of that particular failures, not detecting while the failure actually happens. So this is the difference between predictive maintenance. So don't get confused with predictive maintenance being able to detect when the failures of machine are happening. You need to detect at early stage, so before they actually happen, so that you can reduce the downtime. So why predictive maintenance is necessary? So there is a huge cost involved with unplanned downtime. So suppose there is a manufacturing facility. So for example, you can consider here only in a nearby area, there is a huge manufacturing facility in Belgavi region, which is nothing but acres. They manufacture toys over there. So there, the toys, how they are manufactured, they are continuously being manufactured on the conveyor. So suppose they are manufacturing a toy, for example, consider piano or musical instrument which is played by the small children. So what happens? So usually there is a conveyor. On that conveyor, the each and everything is going to come one by one. So there are a number of operators which are sitting along that conveyor. So first operator is supposed to perform first task, second operator is supposed to perform second task, third operator is supposed to perform third task. So likewise, so we also have delivered one project to them for that particular this thing, your sponge bullets loading in the toy guns. So what usually happens is, if there is a maintenance or if there is a downtime at one end, it is going to affect the entire production line. So they usually manufacture almost 3 to 5 pianos every minute, right from start to end. So if one particular system or if there is a defect or if there is a downtime at one particular operator side, then it is going to affect it is going to increase the downtime of that entire production line. So this particular downtime, it is going to result in huge manufacturing and production related losses. So the cost of unplanned downtime is huge. So because of this particular reason, the predictive maintenance is required. So unplanned downtime, it can generally cost manufacturers with huge losses per hour, depending upon the industry. So it can go up to 242 hours annually to unexpected breakdowns. And because of this, if there is a large manufacturing facility, it can incur losses in millions of rupees. So because of this, what happens is, rather than traditional approaches for that particular maintenance, which have always tried to minimize these losses, but traditional approaches, they usually come with significant limitations. So whatever traditional approaches are used for these maintenance and related things, they are going to come after the failure happens or failure actually happens. There is another thing called a statistical process control. Again, I will be dealing it in the upcoming sessions in performance improvisation. So first we'll discuss what is traditional maintenance strategies or traditional maintenance strategies. So first one is reactive maintenance and second one is preventive maintenance. So what reactive maintenance is? It is usually run to failure method. So if there is one equipment, so if that equipment fails, it will be repaired only after it breaks down. So because of this, what happens? So it is going to cause upfront maintenance costs. Okay, so it is going to result in unexpected downtime, higher repair expenses, and loss of productivity, because for that much amount of time, your system will be stagnant. Next one, preventive maintenance. So preventive maintenance, how it is done? So usually aeroplanes and all, they implement preventive maintenance. So there is a calendar-based maintenance method. So every 15th of the month or every 25th of the month, what you need to do is, you're going to inspect everything and you are going to perform the maintenance. So reactive maintenance rather than reactive maintenance, preventive maintenance is better because obviously it is going to reduce the downtime or reduce the risk of breakdowns. But it often leads to over maintenance and the costs which are associated with over maintenance. So there might be cases where the system doesn't require any maintenance at all. There might be cases where the machine or this thing doesn't require any maintenance at all. So in that particular case, what happens is servicing equipment that doesn't need it, usually you end up in servicing that particular equipment. So other than that, this also doesn't eliminate unexpected failures. So because of this, so just for an example, what we have done is I've given an example, a pump might be serviced every 3 months, but sometimes it could have safely run for 6 months without any issues. So because of that, you're servicing, or if you're servicing it for every month, or if you're servicing it for every 3 months, whatever costs are associated with servicing that particular pump, they will be in vain. Other than that, there can be unexpected failures if you're going with preventive maintenance or you're going with reactive maintenance. So what actually predictive maintenance is? So to overcome the disadvantages of preventive and reactive maintenance, this predictive maintenance comes into picture. So predictive maintenance, it is usually associated with AI-driven approach itself. So for predictive maintenance, it requires data. Without data, even predictive maintenance is not going to work. So it is an AI-driven approach that usually uses machine learning models, which are trained on historical data to predict when the machine is likely to fail. So instead of relying on fixed schedules or waiting for breakdown, as in case of reactive maintenance, predictive maintenance systems, they provide data-driven insights and they tell maintenance team right when to act. So they are going to predict the maintenance in early, and on the basis of this. So if it is an AIoT related system, artificial intelligence of things, then it is going to notify the maintenance team regarding the maintenance schedules. So suppose there is a chances of failure, or suppose there is a chances of downtime 2 days after current date, then they are going to inform the maintenance team to make the servicing of that particular component so that breakdown can be eliminated. So key inputs for this kind of predictive maintenance. So I already stressed predictive maintenance. We are dealing with real-time data. Other than that, we are also dealing with the historical data. So in this predictive maintenance, what we do is real-time data is used as well as historical data is used to identify the patterns which humans might miss. So over the time, the system learns what normal operation is, and it flags any anomalies or flags any deviations as early warnings of that particular maintenance. So data inputs, again, for any AI related systems, you need data in manufacturing systems. Data, if you are considering manufacturing part or predictive maintenance part, then data is usually going to come from sensor nodes or data acquisition devices, which are usually or normally attached to that particular system. So if you consider an example of industrial robot, each and every industrial robot which is implemented in the industry usually comes with a data logger. So you can analyze that particular data and you can come to know, or if you train on that particular data, then in that case, predictive maintenance is going to work effectively in that particular case. So again, I'll just give some examples of real world predictive maintenance. So where predictive maintenance is implemented, again, General Motors, they use machine learning models that process data or data from thousands of IoT sensors which are installed at assembly lines. So these sensors, what they are going to do is they are going to monitor temperature, vibration, and cyclic load. So using this data, the AI system, it is going to predict potential failure weeks in advance. So this can allow some repair time or schedule planning wherever the downtime is predicted or wherever the maintenance is required. Second, this one was pioneer actually. It was known as MindSphere, Siemens MindSphere. It was Siemens MindSphere. Now it is Siemens Insider. So they have developed their own IoT operating system. So this is going to collect and analyze machine learning data from all their factories worldwide. So on this data, they are going to train AI or ML related systems on this particular global data set. So because of this, it is not only going to provide the predictive insights for their individual factories, but also it is going to give an analysis of their entire factories or of their all their factories which are present globally. Next example is automotive industry. So in automotive industry, you can consider an assembly line. So here AI can be used for the analysis of the sensor data. So there will be many of the robotic systems which are deployed over there. So here on assembly lines, so just for example, you can consider robotic welding arms. So it can be used for early detection of joint wear. So On the basis of this, proactive maintenance can be scheduled, so which can reduce the costly downtime, ensuring the uninterrupted vehicle production. So what are the benefits of predictive maintenance? So if we consider the benefits of predictive maintenance, it has seen, so globally, all the industries which are using predictive maintenance in their operations, so they have seen 30% reduction in the maintenance cost. Other than that, breakdown times are reduced. So it is going to alert prior to the breakdown. So because of that, so breakdown times will be drastically reduced, except few cases of unexpected failures. Next, extended equipment life. So you are servicing the equipments whenever they are required. So because of this, what happens is machines, they last longer. They are serviced at optimal time, neither too early nor too late. So additional benefits which can be included or which we can consider are worker safety, preventing catastrophic failure. This comes in addition to the above mentioned benefits. Higher productivity, because your downtime will be far less compared to the traditional maintenance approaches. And other than that, sustainability impact by extending equipment life. So if some component you are going to use that component, or if that component is going to fail in almost 6 months by traditional maintenance strategies, using predictive maintenance and by your maintenance schedule, optimizing your maintenance schedule for that component is expected to last longer. So this way you can improve the sustainability of that particular component. So here, first thing what we have discussed till now is, we have discussed artificial intelligence in manufacturing, how you can use, in what particular fields you can use artificial intelligence and machine learning techniques in manufacturing. Other than that, second important thing which we have discussed is predictive maintenance. So how predictive maintenance or how AI and machine learning techniques fuel predictive maintenance or fuel a concept called as predictive maintenance, which can be used to overcome the disadvantages of traditional and present reactive maintenance techniques. Next, third thing. So in this third thing, what we'll be discussing is quality control and inspection. So in the agenda itself, I have discussed, we'll be transitioning from implementation in manufacturing to maintenance to quality control to supply chain to industry 4.0. So here, next thing what we'll be discussing is how artificial intelligence can improve quality control and inspection. So that is how to achieve perfection through computer vision and advanced analytics. So there are many techniques of quality control using artificial intelligence, but whenever you see or whenever you hear the term use of or application of artificial intelligence for quality control and inspection, first thing or first major technique which is used is computer vision in that particular case. So what quality control, why quality control matters? So because quality control, it is the foundation of any basic manufacturing process. So whether it may be a small thing or whether it may be a large manufacturing setup. So it determines how fast or efficient a production line is, and if the products actually fit the planned yield. So traditional methods of quality control, they are heavily relied on human inspector. So you can see quality inspection, many people being employed to quality control department, visual inspection department. So it heavily implies or heavily depends on the human expertise that is visually checking of the parts and products. So while human expertise is valuable, so there is no match for human expertise, or AI is not a replacement for human expertise, but AI can improvise the way in which the quality control is done at present using human expertise. So it can give suggestions or it can provide the analysis of the minor things which humans may fail to detect. So while human expertise is valuable, manual inspection, it is usually, what are the disadvantages of current quality control or current quality control inspection? So human inspection, it is slow and labor intensive. So if you are deploying an AI-based system and if you are comparing it with human inspection, comparatively human inspection will be slower. More employees are required for human quality control and inspection. Next, it is prone to error and inconsistency. Consistency is the key to quality control. So if you are going for human inspection, so sometimes it may be prone to errors because of some kind of this thing, or there may be inconsistencies in your quality control and inspection. So usually the primary key for quality control or primary key for quality implementation is your consistency. So each and every time, whatever product you're flagging it as non-defective or whatever product you're flagging it as defective, so there should be consistency in that particular thing. So again, it is limited by human visual capabilities. So human inspection, if wherever you are using human inspection, it can be implemented in few industries. But for example, you consider uh, silicon chip manufacturing industries like Intel, AMD, NVIDIA, and all. So their human inspection, it is practically impossible. So you cannot go for human inspection anyhow. So in this human inspection, it is usually related or it is usually limited by human capabilities, and it is impossible to scale for 100% inspection. So because of this particular drawback, you can implement artificial intelligence, or more specifically, whenever we are talking about quality control, you can directly say that you are going for vision related inspections, because 90% of the quality control or 90% of artificial intelligence implementations in quality related field, they are related to computer vision. So one of the most important this thing in AI, or one of the most important term in AI in quality control or application of AI in quality control is visual inspection using computer vision. So how it is done? It is done with the help of high resolution cameras. So there might be different cameras depending upon the application which are required. So you can have thermal cameras, you can have high resolution cameras, you can have 3D cameras, depend what kind of product you are trying to inspect. Next, what are the advantages of visual inspection with computer vision? So first important advantage of implementing visual inspection with computer vision is the speed. So these AI systems, they can inspect hundreds of parts per minute, which is far more than the human capabilities. Next, accuracy. So I have already stressed it in previous slide. Consistency and accuracy is important. So they can detect it with accuracy. Other than that, they can also detect the microscopic defect which are invisible to the human eye with consistent precision. So this term is important. Precision term is very important in quality control and inspection. Next one, consistency, again the same thing. So next, another advantage is they can work 24/7. Next, learning. So suppose you implemented a AI system which learns on its own. So you have trained it on some particular data, and further what you will be doing is you will be putting it on learning mode. So it can continuously learn and improvise itself. So it can detect new defects or patterns based on the feedback. So again, we'll see some real world examples. So how artificial intelligence and machine learning is currently being employed in different industries for quality control and inspection. So first example I have already given, BMW has deployed a deep learning models, or BMW deployed trained deep learning models, usually convolutional neural networks which are trained on transfer learning approaches to analyze car body surfaces. So these models, what they are going to do, they are going to identify some kind of surface defects or defects in painting which are usually invisible to human eye. Because of this, what happens is each and every product, it meets their quality standards effectively and consistently. So before leaving the assembly line. Second example, you can take Coca-Cola's bottling plant. Coca-Cola's bottling plant, AI-powered vision systems. So they can monitor the fill levels. They can monitor whether the cap has been placed properly. They can also monitor the label accuracy. So whatever label has been printed on those Coca-Cola bottles, whether it meets the expectations of the accuracy, whether the cap has been placed. So because of this, what it can do is, so the system can effectively identify underfilled bottles, crook labels, or damaged packaging in real time instead of relying on random sample checks. So in such huge, so if something or if some product line, it is going to produce thousands of units in a minute, then it is very difficult to perform manual quality inspection over there. So usually inspection is done on the basis of samples. So instead of relying on samples, if you are going for an AI-based visual inspection system, what happens is you can continuously monitor the particular quality. So whether it may be underfill, whether it may be overfill, cap placement, label placement, or any other kind of defect which can be existing in real time without just relying on the samples. Another example, most important one, electronics industry. There is no substitute for human inspection in electronics industry. So AI vision systems, they are widely used in electronics manufacturing to inspect PCBs or printed circuit boards. So PCBs, if there is a single layer PCB or double layer PCB, usually the defects can be inspected. But suppose you can consider PC motherboards or mobile phone motherboards, here the PCBs will be multi-layer, so it is very difficult to identify the defects in human naked eye. So there can be some kind of quality issues or even operational issues. Whatever motherboard you are assembling, it may not operate at all because of misaligned component that can cause failures. So to avoid such defects in future, rather than inspecting after the complete motherboard has been assembled, you can implement stage-wise inspection using AI vision systems, which are going to detect such kind of defects. So they can be manufacturing related defects in the PCB, or they can be assembly related defects. So some component is missing, or some component has been misaligned, some component has been placed in some another orientation. All such things can be monitored using AI vision systems. So AI vision systems are currently used in all manufacturing or electronic manufacturing related industries which manufacture such multi-layer PCBs. Next one, we'll be proceeding now to process control improvisation. So here again, statistical process control with AI. So what is the statistical process control? So traditionally SPC, so here you are going to implement statistics. So technically speaking, artificial intelligence and machine learning, it is not a new concept. Okay. So even though it is popular at today's date, it has been in presence since 1965s with the development of first neural networks and so on. So what the thing is, due to the lack of data, it was not implemented on the wide scale. So as I've explained at the start of the session itself, in industry 4.0, usually the transition happened when the data or enormous amount of data was available. So at present, it has transitioned to, or it is currently transitioning into industry 5.0. So here, before artificial intelligence, so whatever data was there, so their statistical techniques were implemented to analyze these particular things. So it can collect the measurements at different production stages, or it can use statistical charts to detect variations. It can analyze limited number of parameters. So what is the downside of traditional SPCs? It struggles with complex patterns. So if you have huge amount of data, then it is going to struggle with complex pattern. Other than that, it is going to fuel reactive approach. So because of this, what you need to do is you can go to AI enhanced SPC. So initially, whatever SPC has been employed, so that can be enhanced using artificial intelligence techniques. So it learns from multivariate data streams. So if there are multiple data streams, so if there are different parameters of different types again. So from that multivariate data streams, it can learn. It can also identify minor changes or minor anomalies in the normal working operations. So again, it is the main this thing of predictive maintenance. It is going to predict failure before the or earlier in the process. Then also it is going to, because of this, it is also going to save time and costs to early detection, and it usually fuels proactive approach before the defect occurs. So just for example, you can take the example of Intel. So Intel, what it does is it uses machine learning models to monitor highly complex semiconductor wafer manufacturing process. So this is done stage-wise. So instead of waiting till the entire this thing, or instead of waiting for the final inspection, artificial intelligence and vision related techniques, they can process variables in earlier stages of that particular manufacturing, and they can predict which wafers are likely to fail in future, thereby preventing the loss of resources and thereby preventing the cost associated with the further manufacturing of that particular thing. So in such particular things, or using such, these are just examples of how statistical process control can be enhanced with AI. So the statistical process control, it is not new. AI also is not new. The only thing is AI, it became so popular because of the presence or because of availability of the data at present date. Next application of quality control and inspection, again, non-destructive testing. So this is, again, it is usually done in aerospace, automotive industries where you don't want to damage the product by testing it. So in industries like aerospace, automotive, you can also consider construction. So NDT, it is critical for it, ensuring that structural integrity is maintained without damaging that particular product, because usually costs which are implemented or usually costs which are involved in manufacturing will be in millions. So for example, you can take fighter jets or this thing. So cost involved in manufacturing are so drastically high that you cannot like damage the product during testing. So here your NDT comes into picture. So artificial intelligence can be also used in non-destructive testing field. So it can be used for ultrasonic testing, where artificial intelligence analyzes wave patterns to detect micro cracks and internal defects in the material without actually damaging that particular material. Radiographic testing, AI enhances X-ray and gamma ray imaging. So you can consider an example of nuclear power plant for predictive maintenance if there are some minor cracks for gamma ray imaging, or you can consider X-ray imaging. Again, it is related to aerospace industries. Next, thermographic testing. AI interprets thermal patterns to locate anomalies which are invisible or which are invisible to naked eye. Some kind of heat related patterns in this thing it can detect. So what are the benefits of AI in quality control? It usually, sorry. Okay. So it usually achieves 99.9% of inspection accuracy, which is impossible for human inspection to achieve. So AI vision systems, they are capable of detecting defects which scales defect at scales, and they are usually invisible for human eye. Other than that, 100% inspection coverage. So I have given an example of Coca-Cola bottling plant where thousands of units are being bottled in a minute, just for an example. So here the inspection is on the basis of the sampling methods. You can't inspect each and every bottle. But if you are implementing artificial intelligence in quality control, so it is going to perform 100% inspection coverage. So using AI, it is possible to inspect each and every bottle rather than going for samples from the batch production for inspection of that particular or items which are produced on that particular production line. Other than that, 90% defect prediction. By detecting issues early in the process, you can save the time and costs which are required to produce or which are required to manufacture that particular product throughout the production line, and at the end you will come to know that in the inspection that it is not going to work because of this particular reason. So real-time inspection happens, early issues are detected in the process, and because of this material wastage is also reduced and costly rework on that particular thing. So example I have given is electronics industry, PCB manufacturing and assembly. So if some component is, so in PCB assembly lines how it is, so there are like multi-head pick and place machines or multi-head robotic pick and place machines. So based on the design which is given, so they are going to automatically place all the components at higher speed. So if there are 100 components, all the 100 components can be placed in almost like 25 to 30 seconds of the time on that particular single PMP machine with double head placing capacity. So it can achieve as high speeds as that. So in this particular operation, if some product orientation, so suppose any diode is to be soldered in that particular operation. So if the people who are from electronics background, they'll come to know if you're going to solder it in another orientation, obviously it is going to cause the failure of that particular this thing. So such kind of defects can be detected using this AI based quality control and inspection system, and because of this costly rework at the end can be avoided. Now we'll come to the next thing, which is nothing but the process optimization. So process optimization, it is not a technical list difficult term. Process optimization is what? It is a self-optimizing production systems through AI. So whatever production system it is being implemented, so based on the data, based on the yield, data related to how it is implemented, what parameters go into the production of that particular thing, what parameters go in operating that particular production line, and how much yield has been produced over the particular period of time. So on the basis of this data, it can learn to optimize the results so that it can give maximum yield in minimum amount of time. So this is the primary requirement of any manufacturing related process. So you have to get maximum yield, production time should be reduced, defects should be reduced, quality control process should be optimized so that you are going to save money on the time related this thing. So what is the complexity in traditional optimization approaches? So again, if you are considered general manufacturing, so manufacturing again it is highly complex domain with hundreds of variables they are going to interact simultaneously or directly impacting the yield and quality. So if you're suppose you are manufacturing some kind of mechanical component, then there may be operations which are involved. So you might have machining related operations. After that, you might have drilling related operations. It might go to one station where it might be drilled. After that, it might go to lathe or CNC related area where it might be precision machining might be required or manual machining might be required. After that, some another operation might be performed. So such kind of processes. So each and every machine has got hundreds of variables which interact simultaneously, which is indirectly or directly it is going to impact the yield, quality, and efficiency, as well as in the end everything is related to the cost. So what happens with traditional related approaches? Usually it is manual trial and error, static rule based system. So static rule based system is what, in simple terms, it is if else thing. So you are going to write some rules. If it is this, then do that. So it is not mandatory that each and every time this is supposed to work, because you are going to write static rules. You are not going to change it dynamically based on how the system is performing. Next, operator experience and intuition. So this is again important. The person who is operating that system, his experience and intuition of the way of handling the problems also matter. So these approaches, these are usually slow and inefficient. So again, they require repeated testing. On the other hand, they also fail to handle multivariate complexity. So too many variables, it is not possible using traditional approaches. So on the other hand, if you consider AI-based or AI-driven optimization, you can have massive data sets. So for example, I have given the example of Siemens, MindSphere or Insight Hubs. So data which is coming in that particular IoT operating system, it is coming from all of their global factories. So it will be huge and enormous amounts of data, and it will be usually multivariate data. So you can have massive data sets from sensors and production logs. So again, you can predict the outcomes of different parameters combinations. Rather than going for static rule-based approach, you can try with different parameter related combination and you can test those particular things. Again, it continuously adjusts the machine settings in real time. So for example, just for example, so this has got no technical significance. So you can consider a part which requires 4 different drills at 4 different locations. So kind of parameters to be adjusted for that particular part, and for the part which requires 2 different drills at 2 different locations, kind of parameters to be adjusted, they usually differ. So this is where AI-driven optimization comes into picture. So if you're optimizing using, or if you're optimizing process for control using this AI-driven optimization, then obviously it is going to suggest you the optimal parameters. Again, adapts to material changes and environmental variations. So now we'll come to reinforcement learning in action. So what reinforcement learning is? So in reinforcement learning, so there are 4 basic steps. So first one is exploration. So AI agent, it tests different parameter settings within safe boundaries or within its own environment. After that, it gives the feedback, or system receives the performance metrics. So it can be whether you are implementing it to quality control, whether you are implementing it to production related line, or whether you are implementing it to process improvisation like I have discussed in the previous slides. So it can be related to yield, or it can be related to the defect rate, how many defective pieces are being detected in that particular batch, or it can be also related to energy consumption. So system receives the feedback on the basis of the test which AI agent conducts using different parameter settings. Learning is the third step. AI learns which settings produce the best results through repeated trials. So in the first, this thing itself, when I mentioned reinforcement learning, I have mentioned that it is a trial and error based approach. Next, optimization. So over the time, it discovers optimal conditions that can maximize rewards and minimize penalties. So it is usually a reward based approach. So for example, if your goal is to increase the yield, so whatever parameters you are experimenting, it is going to check whether the yield is increasing. If it is increasing, it is going to get the reward for that particular approach, or else penalty will be assigned. On the basis of this multiple trials and errors, it is going to come, or it is going to conclude in an optimal approach in which that particular yield can be made better. So that is the primary goal. Your yield should be better, or you should get maximum yield. So reinforcement learning can detect with what particular input parameters you are going to get maximum yield by trial and errors in the safe boundaries. So as an analogy for understanding the reinforcement learning, you can consider, so I think many of the people are aware, or many of you have played Dr. Mario game whenever we were young. So in that Mario game, so whenever you are completing the level, what happens is, while that Mario goes into the fort, you can directly go into the fort, or you can jump directly on the flag from the top. You can climb the stairs, jump on the flag, and then you can go into the fort. The points which you get when you directly go into the fort, and the points which you get when you jump on the flag and go into the fort. So there will be some kind of sound effects, there will be some kind of firework. So you can consider reinforcement learning as an analogy to that particular thing. So if you are going through that shortcut, your yield will be more with that particular optimal approach. It is going to reward you with fireworks, it is going to reward you with sound tone. If you're going with normal this thing, obviously you are going to achieve it. It is a production line, means it is going to yield something. But where reinforcement learning comes into picture, maximizing that yields on the basis of different trials and errors, or combination of different parameters as a trial and error. So practical example you can consider for reinforcement learning is the injection molding. So injection molding, people from mechanical background usually know what injection molding is. It is widely used for production of the plastic parts, where plastic is heated and it is injected into the molds. So almost majority of the plastic parts or plastic components which are available in market, they are injection molded. So the quality depends on the multiple parameters such as mold temperature, injection pressure, cooling time, or material batch related properties. So traditionally what happens is technicians, they can spend hours adjusting these variables to find the right balance for these parameters, where even small deviations can lead to some kind of wrapping, or they can lead to some kind of surface defects or dimensional inaccuracies. So AI driven optimization systems, they are now being implemented in mass injection molding machines to detect the best settings for each new material batch. Automatically they can adjust the cycle times, as well as they can improve the surface finish as well as the dimensional accuracy. So what is the benefit of AI in process optimization? So first thing, it is going to reduce the cycle time. Second thing, it is going to reduce the defects. So what defects you are going to get if you are going to go with such kind of parameters which is going to maximize the yield. So primary, as the yield is maximized, obviously the defects will be reduced. Next, energy savings. You are doing something in lesser amount of time as with traditional approach. So obviously again you are going to get the benefit of energy savings over there. Again, additional benefits there are, you are going to get higher yield from the raw materials, reduced variability in product quality, lower cost through less work, and waste, faster decision making through real-time adjustments and scalability across global plans. Now the final stage is supply chain and logistics. So supply chain, we have seen application of artificial intelligence and machine learning till now throughout the production systems. So first we've seen it in manufacturing, how you can use it in manufacturing, how you can use it in quality control. We have seen real world use case examples of that. We have also seen how you can use in current process improvisation. We have an ongoing setup, how you can improvise it to provide maximum yield on by adjusting the parameters. So last one is the supply chain. So what are the, first we'll discuss what are the disadvantages related to the traditional supply chain related approaches. So first important disadvantage. So if you look towards the previous slides or previous concepts as well, the first large primary disadvantage was in each and every traditional approach, you have word reactive. Everything is done after it happens. Defect, after the defect occurs, we are going to repair it. Similarly, in other cases also. Similarly, in supply chain also, in traditional approach, it is largely reactive planning. After that, overstocking. So this is the problem faced by most of the industries. So usually they tend to overstock the inventory. So unaware of the demand or unaware of the demand forecast, because demand forecast systems are not existing. So because of that, they are going to overstock to avoid shortages. So this can result in higher stocks because funds will be invested somewhere in the particular stocks. After that, understocking to minimize holding costs. So like overstocking, another thing is understocking. They might understock that particular inventory, but if demand rises, they fail to deliver that particular yield. Next, limited visibility across the network and slow response to disruptions. So how AI-based or AI-powered supply chain management, how artificial intelligence can improve supply chain management. So it can analyze the patterns from the data simultaneously. So this usually includes the patterns of the demands, your historical data, how demands are increasing, how much demand was there previous year, how much demand was there before that, at what particular point of year. So if it is a seasonal product, at what particular point of year your business is going to get maximum demand for that particular product whenever there will be slack. So all such conditions, they can be analyzed, and likely a production plan can be suggested by that particular AI-based system. So it can also include transportation related conditions, weather forecast, and market related trends. So this transforms the supply chains from reactive to rigid, proactive, and adaptive, because it will be in real time and it will be continuously analyzing the patterns from the incoming data or whatever data we are feeding. So it can be adaptive as well. So it can learn from new patterns. It can adapt to those particular changes in the thing. So accordingly, your AI can be used for improvising the process of supply chain. So these are the primary applications, use of artificial intelligence applications in supply chain. So first one, demand forecasting, I already told. So AI models can learn from the real-time sales data, seasonal variations, and they can forecast the demands. Supplier management, so they can evaluate the performance of that particular supplier. So whether he is able to supply those raw materials, what kind of defective products, if you are ordering for raw material in quantity of thousands and lakhs, how much defect rate is expected, inventory optimization, reducing understocking and overstocking, as I have discussed in the previous this thing, and logistics and routing. So this real-time data such as traffic, fuel cost involved in delivering that particular product to the end business or the customer, as well as weather forecast to optimize the delivery routes. So in rainy seasons, which particular mode of transport to be used, and all such things can be done using AI related applications for the supply chain. So again, real world examples, Toyota just-in-time supply chain. So Toyota, it integrates ML models that predict demand based on the data which it is receiving from their showrooms or dealership sales, customer orders, as well as the market conditions. So these models, what they do is they allow the suppliers to deliver exactly what is required while minimizing and maintaining the responsiveness. Next important thing is Amazon AI-driven warehousing. So if you search YouTube for Amazon warehouse robots, you are going to get that particular insight of how Amazon is going to use artificial intelligence or this thing for AI-driven warehousing. So here what happens is there are massive network of robot which is deployed. So it is going to optimize which orders to be scheduled. So from which location the order has come. So there is something called as fulfilled by Amazon, where inventory is stocked at the Amazon warehouses itself. So entire process, right from collecting the product from that particular shelf to packaging and then dispatching it to the particular end customer, it is done by the robots. And here your artificial intelligence come into picture. Again, Walmart demand prediction similar to Amazon. So demand usually rises during holidays or during festivals and all such things. So this demand prediction and stocking their retail outlets on which particular product is going to be expected or maximum sales are going to be expected for which particular product during what period or during what particular festival or during what particular holidays, that can be done using this particular things. So what are the benefits? First important one is 50% forecast accuracy improvement. Next one, 30% inventory reduction. You don't need to hold the stock. And next 25% logistic cost reduction. So majority of the times due to environmental factors or due to breakdown, you rely on the logistics, but you end up paying more costs. So because of this thing, if you implement such artificial intelligence techniques or data analysis techniques using this on the supply chain thing, then you can improvise these particular things. Now next, finally, we are coming to the concept of digital twins. So digital twins, again, I'll just explain it in short because this is a wide or broad concept. It is practically impossible to go much details in this thing. So you can understand digital twins is virtual replicas for simulation and optimization. So this usually matters when the product which you are manufacturing is like high value product. So digital twin, it is a virtual replica of the product, physical machine or process. So in non-technical terms, just for an example, if you have not understood, you can consider it is an avatar or it is a replica of that particular product. So you can have product which is actually deployed and there will be a digital twin for that particular product. This digital twin, what it is going to do is, it is going to collect the data from the actual product to optimize the performance of that actual product without stopping or without the downtime of that particular actual product. So unlike static digital model, digital twin is a connected real-time physical counterpart through sensors. So when I give the examples, you'll understand in depth what digital twin is. So this connection allows the twin to reflect the current state, behavior, and performance of that particular physical entity. So here, it is not just simulation, it is the simulation of that actual product. So whatever data is coming for that simulation, it is coming from that actual product. So this you need to understand. So digital twin of a for example, you can take digital twin of a manufacturing machine. It continuously receives data on temperature, vibration, and power consumption. So this data is coming from the actual machine, not from the simulation related readings. Next, digital twin of a factory production line. It simulates material flows, bottlenecks, and throughput. Next, digital twin of a product like car engine. It can simulate wear and tear across the life cycle. So whatever sensors are present in the car which is actually running on the road, so using that data, it can predict or it can simulate those conditions in that particular system and it can predict the wear and tear across its life cycle. So what is the basic advantage of digital twin? So the power of digital twin, it usually lies in the reliability to run simulations and what if scenarios. So here what we do is, instead of making changes in real world, which may be costly and risky. So just take an example of a car. Instead of directly making the changes in engine, which is again costlier approach. So what it can do is, it can make those changes in the digital twin and then try to analyze what will happen if I make such changes in that particular performance related thing or particular this thing. So what might be output, and on the basis of that, whatever results it has got, it is going to adapt the actual model or actual physical model. So engineers can test modifications in virtual twin and predict the outcomes before the implementation of the changes in their actual physical product. So what is the role of AI in digital twins? So first one, prediction. So they can identify patterns in signal, again, predictive maintenance. Next one, optimization. It can suggest the optimal parameters for the operation of that particular engine or this thing. Adoption. So as input data changes, so for example, new materials or environmental variations, then twin is going to update the prediction and automatically the system is going to work on the basis of those updated prediction. And last important one in digital twins is autonomy. So in advanced system, what happens? AI-enabled digital twins, they can directly adjust rather than simulating and then giving you the suggestions on the basis of real-time data which is coming from the physical model. So they can directly adjust to real-world operations based on the simulations or based on the what if related rules which it has performed. So if this is the condition, then this. So just as an analogy, you can consider simple thing, car which is running on road, it has to brake, or your ADAS systems and all have come into picture. So here, what if I run with this particular speed? How much will be the braking distance? So this can, all such conditions can be simulated prior to the executing of those conditions, so that decisions can be made easier. So again, industry example is GE Aviation. So they have implemented digital twins far before. So here, one of the most widely cited examples it is for digital twin technology. So those jet engines, usually those are complex and those are expensive assets. So this digital twin technology directly impacts both safety and performance related issues as well as cost of operating those jet engines. So what GE has done is GE has developed digital twins for individual jet engines. So these twins, they continuously receive the sensor data related or input parameter data for normal operations of such engines, and this twin it is going to simulate the wear and tear based on the operating conditions or actual operating conditions in which that particular physical product is operating, and then this is going to enable condition based maintenance where servicing is required when it is required instead of following a proper rigid schedule for maintenance. So this, because of this, what we can do is we can avoid unnecessary downtime as well as the cost. So this is the classic example of digital twins. So again, I've already mentioned this. What are the benefits of digital twins? It can be used for reducing the downtimes, faster design related interactions. So this is important from if R&D point of view. So if you want to make some changes in the actual product based on the current conditions, if you want to add some changes, so this digital twin is directly and it is going to reliably adapt to those particular changes and going to give you results. What is going to happen if you are going to make such changes in your particular this thing? So these design iterations will be faster, which otherwise are going to take total design life cycle into consideration. Next, enhanced life cycle management. So it is going to improve the assessed performance and it is going to also improve the life this thing and improve collaboration. So digital twin serve as a shared reference point for engineers, operations, and decision makers across different locations, which can enable better communication and decision making. Now, next concept is cobots or human-robot collaboration. So again, this is primary application of AI, which is almost like it is a recent thing. So rise of cobots in most of the industries. So before cobots, only the industrial robots were into picture. So now almost majority of the industries, so where lightweight and repetitive tasks are required rather than going for robot related assemblies, robot related weldings and all, you have a cobot into picture. So before going for cobot, let us understand the difference between traditional industrial robots and your collaborative robots. So traditional industrial robots, they are operated in isolated fenced off areas. So in the work area of that particular robotic arm, so it is risky in that particular work area. So usually they are operated in the restricted environments. So they are extremely powerful, fast and precise. Other than that, it can be dangerous if humans come too close to that particular thing. Plus, there is a lack of flexibility to adapt. So this factor you have to consider the most rather than considering other factors. Next, requires complex programming for new tasks. So this lack of flexibility to adapt to the changing needs is where cobot comes like more efficient compared to the traditional industrial robots. Other than that, safety is primary concern where cobots come into picture. So cobots usually they are collaborative robots. So these robots are usually designed from Industry 5.0 perspective. So next, Industry 4.0 was still AI, data analysis, artificial intelligence, AIoT related things, IoT industrial collection of the data from the sensors, process automation and all. But Industry 5.0 usually will be focusing on shared workspace between humans and artificial intelligence or humans and AI related robots. So humans and AI can work together hand in hand to improvise all those problems which are being faced in Industry 4.0 and before that. So here cobots come into picture. So they are designed to share workspace with humans. They are enhanced with advanced safety features because data which cobots process, it usually comes from the cameras inspection which is happening through the cameras. So whether you are coming in the direct workspace of that particular robot, so if you come, how to adjust the robot so that you can avoid human and robot collision in that particular case. Just for an example, it is also going to monitor the data related to force. So it can combine machine strength with human judgment. So it is going to implement human expertise as well as the machine strength, and it is powered by AI vision. I have already specified this point. It is powered by AI for vision, speech, and learning. Other than that, it is smaller and easier to reprogram. Because it is collaborative, it is very easier to reprogram, or single cobot can be used to perform multiple tasks across multiple domains with ease. So this is not possible in complex industrial related robots, and it is adaptable to changing production related needs. So what are the capabilities of AI related cobots? So AI related cobots, first thing I have told, humans and robots are going to work in collaboration with each other. So first one, computer vision. So like I gave the example, whether you are coming in the area of work area of that particular robot, speech recognition, you can use speech recognition technologies to make that cobot respond to the voice. Adaptive to learning, you can easily reprogram it for different tasks. Other than that,
Excuse
it
me,
also,
sir.
yes.
Actually, we are running out of time. We need to conclude the session.
Okay, okay.
Uh, so, if is there any concluding remark you can give?
Just a second, sir. I'll just jump to the last list then. Okay. So till now, what we have done is, so since we are running out of time, so I'll just conclude this session. So in this session, what we did is we started with use of artificial intelligence and machine learning for production quality and process improvisation. So we have seen different tools or different approaches in which artificial intelligence can be used for improvising that particular, right from production, quality control, inspection, or it can be predictive maintenance. So we have seen different use cases. Other than that, we have seen the industry 4.0 related basics. Also, I have suggested that there is a transition or swift transition from industry 4.0 to 5.0. So while I'll just explain what is industry 5.0 and we'll conclude this session. So while industry 4.0, it has revolutionized manufacturing and automation and data exchange, industry 5.0 specifically stresses on prioritizing human creativity and societal values. So with the arise of more and more complicated AI models, security comes into picture, ethical practices also come into picture. Other than that, your societal values also come into picture. So here what industry 5.0 is going to deal with. Next, human centricity. So even though AI models will be very much advanced, they will be centric to human related thing. So placing a human being at the core and augmenting human capabilities. So for example, you can consider some kind of exoskeleton which is going to improvise the human weightlifting capabilities or related to defense related tasks and all such things. Or in industrial case, combination of the expertise of the human judgment and AI related judgment can be used to improvise that particular task. Next, sustainability. Again, I have discussed what is lean manufacturing, reducing the waste, using minimum resources, providing maximum yield. And resilience is nothing but building robust and adaptable programmable systems which are capable of withstanding supply chain related variations or deviations in supply chain related issues like understocking, overstocking, and all such things. Industry 5.0's primary role is to elevate with creative partners along with AI systems. So AI related systems are going to work in collaboration with human intelligence or human expertise or human judgment at some point of time to deliver better roles of better productivity or better yield in whichever field we are implementing. So in this session, what we have done is we have seen from the basics how AI can be used for manufacturing, what all approaches can be used in manufacturing. After that, we have also seen how artificial intelligence and machine learning techniques can be used in predictive maintenance. Then we have seen process improvisation, your current manufacturing process, how it can be improvised. And after that also we have seen technology for digital twins, how digital twins can be brought into picture so that all those parameters, so rather than implementing it separately, manufacturing, then predictive maintenance, then process improvisation, a single digital twin will be able to handle all those things simultaneously. And after that, we have seen what Industry 5.0 is going to proceed with, how it is going to proceed with current data, how it is going to outcome or how it is going to overcome the problems of the Industry 4.0 related techniques. So with this, what we'll do is we'll conclude today's session. If anyone has any doubts, you can ask me.
Okay. Thank you, sir. On the behalf of the Ashokramani Group of Institutions, I take this opportunity to express a heartfelt gratitude to Mr. Rohit Vijay Kadam, sir, Managing Director of the RoboSap Innovations Private Limited, for gracing us with your presence and delivering such insightful and inspiring sessions. Your journey as an entrepreneur and innovation in the fields of the artificial intelligence, robotics, and automation has truly motivated us. The examples of your groundbreaking products like Photon, Thermogate, and Agrobot have given us a glimpse of how technology can be harnessed to solve the real world challenges. We sincerely appreciate the time you took from your schedule and to share your knowledge and experience with us. Your talk has not only enriched our understanding but has also encouraged our participants to think differently, innovative, and pursue excellence. I extend my gratitude to all the enthusiastic participants for this session. With this, we once again thank you, sir, for your valuable contribution. We look forward to many more fruitful interactions with you, sir.
Ma'am, just 1 second. Please ask for audience. Is there any question?
Okay, I would like to ask the participants, if you have any doubts, please raise your hand, or you can ask the questions into the chat box as well. Let me
Thank you very much, Rohit sir.
Thank you.
Okay. Thank you so
The
much.
session was very informative.
Thank you, sir.
And the
Session was very nice.
concept was cleared from the scratch itself.
Yeah.
Thank you.
Thank you so much.
So there is a question, ma'am. There is a question.
Yes, yes. How can NLP be applied into smart manufacturing environments?
Okay, so NLP, it can be applied to smart manufacturing environments in such a way that you can consider for an example. So usually how the programmable systems differ is, so there is a particular syntax for those particular programming systems. So usually the way in which we interact with systems, so with this ChatGPT kind of things, which is nothing but generative pre-trained transformer and all, at the core it is using NLP related techniques only. So if operators, so usually whenever you are operating a technologically advanced product, what happens is some kind of technical expertise is required to operate that particular machine or this thing. So if you are using NLP related systems, even an inexperienced operator should be able to operate it efficiently, handling all the doubts or if whatever queries are there related to their operational issues. So they can be solved directly by interacting with that particular system. In such way, NLP can contribute towards like whatever gap is there. So if you are adapting technology, technologically aware employees need to handle that particular system. But with the use of NLP, what we can do is, so any operator who doesn't have such kind of technical expertise with that particular thing, even he will be able to operate that particular machine effectively without going into much details related to the technological aspects of how that particular machine operates in the background. So this is how NLP can be implemented.
Yes. Thank you so much, sir. We look forward to see you into the next session as well.
Thank you.
Thank you, sir.
Thank
Thank
you,
you very much.
Thank you.
Again, there is a question, ma'am. Shreya, ma'am.
Yes, sir.
Yeah,
Yes, sir. What are the different measures can be adopted to tackle the cybersecurity related issues?
So because of shortage of time, I didn't find time to speak over that issue. So what you can do is, so here you are just dealing, or this particular session we have discussed regarding the application of artificial intelligence and machine learning in manufacturing process improvisation, quality control, and such related issues. But one slide I was supposed to discuss regarding the cyber security related issues as well. So as we have seen, so these systems are heavily reliant on data. What happens is, they are also susceptible to data breach. So the problem with these kind of systems, they can be tackled by blockchain related things. So one slide was supposed to be there on that as well. So somewhat I was going to handle this issue, but because of shortage of time, I didn't find time to speak about this particular issue. So by implementing blockchain alongside with AI and ML related techniques, you can handle this issue very effectively. So there will be no data leaks, so authenticity of everything will be properly verified using blockchain related nodes.
Yes, sir. Thank you so much, sir. And I think there are no questions from the participants. We would like to conclude this session. Thank you so much, sir.
Thank you, sir.
Thank you once again, sir. Thank you very much. We will
Thank you.
in communication with you in future also.
Sure, sir. It was my pleasure that I got the
Yes.
opportunity to present over here.
Okay.
Yes,
Thank
sir.
you, sir.
Thank you, sir.
Okay. Okay.
Okay. Thank you. Good night, sir.
So, participants, we will share you the feedback link of today's sessions soon in 10 minutes. Thank you.